music. That goes on. And then hop over to YouTube, where I should be up. I don't know how quickly that propagates. I hit start all right. Yeah, that one's going. Reload. I'm not even subscribed to my own channel. All right, there's that. Sorry, I'm looking all the way over at that monitor because that's the one that I use for YouTube and stuff. Pop out. There we go. All right, there's all the chats dealt with. Okay, we're good there, good there, good there, good there. That's my moderation view. This is my events. There are my two chats over here. And then I got the one over there. Okay, everybody is good. Start soon. There you go. And then boot up the scope because it takes forever. I did not sleep last night. It was way too humid. Way too humid for sleep. I had an awful time. The axe shaving continues. It's like every facet of every project that I've been working on lately has been layers and layers and layers of BS that I got to go through in order to get this stuff even remotely starting to function. But I'm getting there. I'm getting there. I've had to learn about containers or pods or jails. Unix has jails. What is it? The one that they wanted me to install for Linux has containers. And then the one that comes with the file server software has pods. They're all just the same thing renamed. Oh, bother, where art thou? I'm doing good. I'm here. I'm here. We're starting up. I'm just starting up. But I'm learning. I'm learning stuff as I go. Once I can deploy an app, which is a pod, and then I can get Mosquito running on that for MQTT. That'll get Node-RED running, and all my automation stuff will run again. And that means that we can then do a stream of Node-RED where I can show the stuff going on. Let's do a patch through. Let's patch through the input signals so that we can see it on the scope. And we'll put that on channel 4. Which means I gotta get out my BNC stuff. I need thinner BNC lines. These are way too rigid. What up, Tim? How you doing? What is up? Ba-na-na-na. Very last time. I like this song. Where did my adapters go? Yeah, there. Oh, that's not one. Oh, they're right in front of me. Okay, let's see. Like me a good complicated beat. Oh, I need to actually get another song queued up. One sec, let me just get this plugged in. Those are a little clunky going in there. Okay, so there's our channel 4. This thing's not outputting yet? 4 volt. 0. I think maybe these BNCs are not great. Been a while. Good to catch you live. Good to hear from you, Tim. Is this? Wait a minute. Did my title actually propagate in there? Or do we have the title from yesterday? No, we've got. Okay, I did a very matter-of-fact title today. So don't get your little cutesy comments when you come in here and try to be cutesy on my stream. Let's just click on DJ Shadow and just have him. Wait. Did I see? Oh, I see. He's going to be in Millvale? Tuesday at 7 p.m., the smallest theater? What the fuck? I don't know if that's quite... I don't know if... That doesn't sound like he's... I think maybe that... Oh, that's the theater. Oh, I see. So that's like an event thing. Weird. I'll do videos and just click on something. Track breakdown. Oh, he's doing all kinds of stuff like that. That's cool. Oh, the prophecy. How big of a donation would it take to have you remove the solder of 4 packs of 18650s with 126 cells each? I don't, man, I don't. That's a heady request right there, is what that is. I ain't doing that shit. Fuck. You're on your own. You gotta navigate that one on your own. I'm not getting a signal here. $1,000 hertz. Oh, there it is. Something had to be knocked into. Oh. My signal's not quite coming in here. Which end is it? It's the pin of this one. Oh, what the fuck? Yeah, and then it doesn't give up. These are subpar BNCs, can be a very big pain in the butt. There we go. Okay. Yeah, usually they use like little tab welds, and I've got a machine that does that. They're very cheap now because all you need is a giant lithium-ion cell and two probes, and you can do little bits of spot welding. They have little timing circuits that are associated with it. And so I bought one. It was like $30, and it works great. But in order to get all the spot welds off, you're gonna have to like pop them and then maybe get a microfile on it. Oh, my dubba-das are triple dubbing today. Nope. Can't control it. Too many dubs and bubs. There we go. We know what the circuit looks like, and at this point, my best strategy is going to be going in here and just fucking ripping up components and replacing them and seeing what the signal looks like on the other side. At the time, I didn't have a spot welder, so I decided to add solder. I was going to fuse them all. The packs then sat for months, and I got a spot welder later. Yeah, it's like the advent of the cheap lithium-ion battery and how much current it can push means that, like, just get the spot welder. Back in the day, for RC cars, we would have soldering rigs for the nickel metal hydride batteries, and you would sit there and heat it up and heat it up and heat it up and add a bunch of solder, and then nothing would stick. So you'd scratch it all up and try again. And some battery packs that I have are downright embarrassing. Now that we have lithium ions, attaching the cells together is super easy. You get that sheet of nickel and you just pop. And you can do it 5 times. You can do like 6 or 8 and have it really, really hold on to that battery pack. And it's a much more professional job. Yeah, we used to have to try to solder it and use all these weird fluxes. And then there was always the danger that you would overheat the cell and it would explode. Oh, sweet. You get to test a bunch of different solder suckers. And yeah, that's good. The Engineer SSO1 Engineer solder sucker was really, really good. And I don't find myself looking for others. And then the stuff that I used to use, and I still use, but I used to too, is the Chemwick or Chemtronics or Solder Wick from Chemtronics. That stuff is good. It's got a little bit of flux in it. A little bit, I think. I'm not sure. Not totally sure, but it's good quality copper. It works very well. Better Welder at the Makerspace has a bike pedal on it for height adjustment. Well, like table height? Oh, the battery welder, I see. Yeah, some of them are like a clamp kind of thing that you do. The one I have is like real cheap and scary. It's a giant lithium-ion battery with probes. It works, but it still scares me. Because, yeah, it's got all the MOSFETs in it so that it gets a huge amount of current, and then it cuts it off so that it doesn't go stupid. Yeah, for things like rework supplies, you find a brand that you like and you know works, and you stick to it. It's unfortunately the way it is, but you don't want to get like a bad brand because that can ruin a repair. You know, you might have a one-of-a-kind circuit sitting on your bench, and if you're unable to get that solder up because your solder wick is subpar, it's really, really, really annoying. So in order to not be really, really, really annoyed, you stick to a brand. That's why you spend a little bit more on what you know. And that's sort of that institutional knowledge, too. You want to have a high wattage iron, get the solder on as quick as you can, or you might damage the cell. That's why it's just a flawed process, because solder does not stick to the end caps of a cell. So the best way to do it is to spot weld it. Oops, that was muted. And it should be the only way to do it. You really don't want to solder cells. It's like, if you have hundreds to do, spend the money on a little spot welder. It's like $60. Like, they're not expensive. And there's one that's even got little spring contacts on it. It's all 3D printed. It's easy, easy, easy. Easy, easy. Saves you a whole bunch of aggravation down the line. Power supply, that's right. We still got to do that. We'll be using hot air today, too. I'm going to pull the chip again. We'll figure this thing out. It's the last thing I do. And it might be. Boop. Boop. Plus, it's just a fun thing to do on a Friday afternoon. You have a mystery circuit in front of you, so you got a bit of an antagonist. And you are their foil. We want to figure out where this thing went wrong. And I think we can get some good progress on it. It's been a slog. It has been a slog, and we've had to get a little bit further into knowledge and design of the types of circuit that make up this kind of VCO. A little bit more than I thought I would have to. If you've got like an intuition, maybe you can figure out what's wrong initially and do it. Or if we got that PDF early on. But instead, we've got to figure out exactly how a TB303 functions. And that's taken quite a bit of time. Very annoying. But we have intimate knowledge of the VCO. Not exactly how the VCO is being structured and working, but we do know why the voltage levels are the level they are when they're traveling back and forth. Because that's plus minus 2 volt audio for output or in. Found a guy who tested a bunch of $20 spot welders, got one of those and used a car battery and it worked well enough. A used car, like, I don't know, I don't have space to store a car battery, but I would definitely trust it over time over a lithium ion cell in my cabinet. But my cabinet is full of lithium ion cells, so I don't know how I feel about that. I don't think it'll one day just go up in smoke, but a different streamer was adamant that the sold up pult was the best soda pult. Selling a put option is a contract between an investor and a buyer. Pult. Soda pult. This thing fucking sucks. No, I'm sorry. They don't know what they're talking about. I don't think that's what they're talking about. Is it? Soldapult. Oh, there's no, They couldn't be further from the truth. They have a veil over their eyes and they're not seeing the reality for what it actually is. They need to wake up. They need to wake up and face the real world. Because these, while shiny and nice to handle, and the other one is like a Fisher-Price color scheme, and it's all plastic and stupid. I shouldn't say they suck, because they do that, but they're terrible. They're absolutely terrible at their job, and you're going to be breathing in more burning plastic than you ever had hoped for. It's not like that thing has a ceramic tip. That's plastic on the end of that thing. I hate it. This is what has made me never want to use a solder sucker ever again. And I don't understand how this other person has no idea what they're talking about. I'll take that to the grave. I'm going to fight this one till death, because this right here is the pièce de résistance of the Engineer SO1. Much like the IBM ThinkPad has their nipple mouse, this thing is a nice little manipulable piece of silicon rubber. That doesn't burn. I mean, it kind of wears away eventually, but it doesn't burn. So what you can do is push this mofo up against any kind of a weird-ass joint, and it will provide you with better suction so that you're pulling air through the solder joint, and it just gets all that solder up. This thing actually is very effective, and you're not going to be breathing in plastic all day. Also, you can just go on Amazon and buy clear 1/4-inch silicon rubber hose with enough of a sidewall. I think it's 4 millimeter, like 4.6 or something like that. 4 millimeter inner diameter, 6 millimeter outer diameter. And you can very cheaply replace these tips. So it's like there's no disadvantage. You can also field disassemble this and reassemble it, assuming that you have grease. I didn't have grease. I put dielectric grease in here, and it's been working perfectly since then. Although it probably could use a little bit of a clean out. Yeah, there's a little bit of solder stuck in there. Well, now it's gone. I don't know what that other person is smoking, because, man, those things suck. They're terrible. This thing's like 30 bucks. They said the cheap ones suck. The Sodapult is actually good, though they were crazy too. They mainly use Metcal desoldering gun. Yeah, so like, you know, everybody has their own pet setup, but I've used the Sodapult and the one that we were just looking at, the blue one with that big thing. I've used them. I've used all of them. I have been working with electronics since I was a teenager who broke into the electronics lab and built a bunch of stuff at my mother's work and got in trouble. Yeah, I've been working with these tools for a long time, and they're bad. They're bad. Burning plastic is not something you want around. I know you could replace the tip, but geez. One of those, an SSO2, alone with one that's a combination 30-watt soldering iron and solder sucker. That's like the thing that I have over here. I've used it once and never again. Although someday there will be a rework job that might need it. But I thought it would be a cool thing, and I could learn how these things work. It works well. It works just fine for the money I paid for it. Beyond that, it's more annoying to get out than the solder sucker and the soldering iron. So I rarely ever use it. That's just how that stuff goes. Oh, this is from my mix. Well, whatever, we'll play Papua New Guinea a little bit. Synthesizer! I have to fix this thing. I really have to fix this thing. Why is it still broken? I've gotten to the bargaining stage. Please just work, and then we can get Dave in here and you can go home. I'm so sick of this. So sick of it. Metcal DS1 desoldering tool is better than the SSO1. I'm looking it up. I'm looking it up. Metcal. Metcal's expensive, isn't it? DS1 pistol grip desoldering gun. 400 and... When in the fuck am I ever going to use this thing? 423. Do you just like to have stuff that's like feels expensive? Is that what it is? You just want it to kind of feel expensive in your hand, and you're like, you just know that you spent $423 on a Metcal. Metcal is the one that makes the obelisk, the 2001 obelisk soldering station. Yeah, it's an add-on to the base station for corpos to buy who have funds, but who's gonna ever ever afford something like this. Ridiculous. So I guess the suction comes from somewhere else, and then the solder cable comes in somewhere else too. Got it for deal on eBay, pretty much. Everything you have secondhand, yeah. Well, it's still utterly bonkers. Let's get this out of here, and then I have my room again. Okay. All this screen space that I have now, and I still have overlapping windows. We are here. Hopefully this works. But we're still here. I don't know if we confirmed if this works or not. Is there a filter out? There's a VCO out. VCO out over here. Filter in, cut off resonance decay envelope. I've got an envelope out. I don't know what that's doing. Maybe that's the stage before the amplifier, and then out would be just the regular out? Because I thought the ADSR, I think, is in the VCA, or whatever functions they are. Use base station and an air compressor. Jeez. Is it, what's it, like Venturi venting? That's weird. Yeah, it's a crazy set. I guess if you were tasked with desoldering a lot of stuff and you don't want to hurt your ergonomics, you don't want your employees suing you for bad ergonomics in your shop, you'd spend that money and it would be just fine. Something is now screaming in my ear. I just got a very high-pitched squeal in my ear. I don't know if the atmospheric pressure is doing something to me. Oh, there, I got it. It went away a little bit. Always afraid of that noise because I've had wall warts go bad on me. And we had like the weirdest situation with a wall wart that was powering these fans in my desk that I used to have, because my computer used to go in the keyboard tray of the desk. So I had fans exhausting all of the hot air. So it would waft up in my face when I was playing games. But that was running off a USB power supply. And eventually some weird stuff started happening where it was like doing a weird type of power out that didn't really make any sense. And like, this is like, it's like a ground thing. Like, what's going on with this? Why isn't it working? So we actually popped open the wall wart. It turns out all the capacitors inside of the wall wart exploded. And so this thing was just a super fun site of capacitor material that was contained within that shell. But there was no external indicator of what happened. All of the capacitors exploded, which is really dangerous. I love it when Twitch doesn't tell me you're live. Smash that bell, like that ring button, and I don't follow and subscribe. I don't know, man. Twitch is Reddit is the one that had the sort of intermittent outage where it wasn't posting comments last night. Yeah, notifications on and all that stuff. Ooh, my foot itches. My foot itches. Pretty much only reworks antique and retro electronics. Yeah, that seems like a good investment then. Have the Twitch page open. Yeah, I find it doesn't like automatically start unless you don't want it to. And then it does. I don't know. Nobody can seem to get video players quite right. What is this track? No. Go down here. Opened up a laptop AC adapter I had, which was doing the same whining. Yeah, it was like a really high-pitched scraping whine and a weird intermittent kind of powery weirdness. Like when I was unplugging a temperature sensor, LEDs would turn on, and it was just this weird push-pull of symptoms. It was not normal. And the reason behind that is that the failure mode of the capacitors, there were capacitors that would go to ground from the power in order to like safety the whole thing, and their failure mode should be open, but if every capacitor explodes, their failure modes are all over the place. So the circuit was reconfiguring itself in odd and scary ways to have been plugged into mains power. think it also got really hot. My foot still itches. Why is my foot itchy? So I'm hoping a combination of new breadboards and... Well, that's it. I'm just hoping these new breadboards can fill us with a little bit more confidence about testing and repairing and troubleshooting these circuits. My newfound knowledge of analog circuits as I sort of plow through all of the different structures that we're dealing with. I'm going through the VM install process on TrueNas scale. Since I've never done it for more than a tutorial, doesn't appear to be that hard. The VMs are fine and all, but I need to get into making app, container, jail, pod containers. I don't... They got like 9 names for these things, but they're called pods in TrueNas, and they're on the app functionality. So if you go through the apps, you can add your own app, and that puts it in a pod, which is a container, which is the replacement for jails. This Linux crap is really just starting to wear away at me. But once I figure this out, I think I can put Mosquito in a pod. And then that'll be my MQTT broker. Apps are limited to port 9000 and higher. Why? Oh, custom, I see. No, this is Linux I'm talking. It's as far from English as you could possibly get. It's nerd speak. Everything is sexual. Bomb. Yes, sure, yes, sure. I'm still not completely 100% on how these filters work precisely. They're like the warp core of filtration. You kind of don't ask questions about them. But it has to do with the millivolt properties of these diodes and how if you sink current down through them, they'll allow certain frequencies through, I suppose. That's sort of what I get from that. There's a lot of reading in this paper, and I read it in a state where I was like almost falling asleep, which is the state I'm in right now. I'm very tired. I did not sleep last night. It was very, very humid and uncomfortable here. So, but I think what we can do is just unga bunga replace the rocks with other rocks and see if we can trick them into thinking. I think that might be the way to go about it. Well, yeah, diode ladder filter, but instead they're using transistors as the diodes because transistors are like 2 diodes. And Moog found that transistors were better matched. And then these are all the way down here are the topologies of the different ladder filters. Topology being just the design. Some have 3. This one, the one we have specifically does not have just diodes. It has transistors, but the 2 leads are shorted, which just leaves us with a diode. Tried to set up the Eclipse and Mosquito container. I'd sent in-stream projects, and it wouldn't start with those port numbers. Ah, why is everything like this? Why did they? Because like everybody was using whatever it was, the TrueNas chart viewer was able to start up Mosquito, TrueCharts. But TrueCharts decided that it was no longer staying with IX systems updates anywhere beyond where they are right now. So there's this big like letter that they wrote about how they're no longer going to support it. And then there's anything you look for adding an MQTT broker to TrueNas is all about TrueCharts. But TrueCharts isn't going to be supported. So why would I install that? So how do I do it otherwise? And the way to do it would be to make your own app. How do I make my own app? I need to do all this stuff. So then apparently now the port number doesn't work out because custom apps start at port 9000. And for some reason, Mosquito, even though it shouldn't give a shit, doesn't like to be over 9000. And I guess maybe that's the joke. They're doing the over 9000 joke. This is why it's taking me a while for us to get back to Node-RED. Node-RED, we will get back to, and I will be repairing the fart box and getting that working, but until I can figure out all of these goddamn Linux projects, it's going to be up in the air. Which one is this one? Probably going to be too wordy. Oh, I remember this song. No, we're not gonna do it. We're not doing that. I haven't tried baking my own scale app, just adding it as a Docker image. Well, so the thing is, like, from what I understand, you look for the app, you don't find it, so you do add custom app, and that's how you add, and it's not really like Docker image, it's adding a pod? I don't know. By all means, you should be able to assign your own port. I mean, who knows? And the thing is, it's like, I only know certain terminology to search, and everything that I'm finding says to install the TrueCharts, and then it's just a couple clicks in order to get the MQTT broker running. But it's like, I don't want to install that because it's depreciated. It's not coming with me to the next versions. I suspect it will. I suspect it will just work, even though it's not currently supported, because I saw all kinds of stuff about TrueCharts and installing it for whatever Dragonfish, whatever the hell it's called, the latest version of TrueNas. So by all means, it probably still works. It's just not going to be supported in the future. Apps I've installed with TrueCharts just work on the beta version? Yeah. Yeah, and then at some point, something will change, and it'll no longer be supported, and then I'll be on my ass again. So I want to make sure that, whatever I'm installing can continue into the future. I don't want to do a whole ass virtual machine just for Mosquito, because Mosquito's so light. It's like nothing. It's just brokering a couple packets every now and then. I would rather that be in like the main system stuff. And I constantly have to defend my decisions. Getting gaslit. Everybody's making me feel like I'm the crazy one. Just put it on a Raspberry Pi, where it's going to blow up one day, because the Raspberry Pi memory card decides, they just decide to stop working. They go, well, guess I'm dead. Boom, Raspberry Pi gone. MQTT ruined. My shop then gets sucked into the earth and down to hell where it belongs. Sounds like I should bake a community app then. I mean, assuming that there's going to be a bunch of people SOL, I'm not sure. I'm not sure if that's exactly the case. I don't know if my research is good at all. Remember, I'm shaving yaks. This is not the original intent of my file server install. I was not supposed to be researching this kind of stuff and discovering there's an entire timeline, like an archaeological timeline of all of these events, these major events. Like, oh, they went to war with them, and now their empire is this, and they call this that, and that and the other thing. Oh, I didn't put the stickers back on the underside of my mouse. I'm getting very frustrated with this kind of stuff. Oh, you don't know the history of our empire? No, I'm trying to install a program that'll make my Furby look like it's farting. I wasn't even supposed to be here today. PXC boot Raspberry Pi, host the image on TrueNas. No worries about SD. Yeah, fuck you. I'm not doing that. I ain't doing that. You can't convince me to do that. That's in the wrong position. Helm chart? Huh? I don't know what any of this stuff is. Oh my god. I did find something Mosquito for TrueNas that wasn't supported. I was like, I don't support this. And I'm like, oh, okay. Those are not very well put on, but maybe the mouse will glide just fine. Yeah, it does. All right. All the different plastics that I have here on the bench. The mouse just needs to kind of feel like a mouse just a little bit. I don't know what Kubernetes is, but I keep reading that fucking word. Going down the rabbit hole so Furby can fart on command. I like to keep it simple for this button. Now, I'll figure it out. The fart box will get resurrected. That's sort of the main goal. The secondary goal and the tertiary goal are Furby farting and the burn the subs being functional, with a little bit of maybe advanced naughty word filtering of some type. Oh, there's no way that I'm going to pronounce it properly because you've just told me how to pronounce it. No. I will now always call it Kubernetes. I want to fix this thing. I want to get started. Listen, the Linux stuff is beyond. I'm drowning in yaks is what's going on. Because in order to do this one thing, I need to do another thing, which led me to another thing, and another, and another, and another, and I think there's more things after that. I have gone through the ringer on this thing. I'm getting very frustrated with Linux at this point. I'm gonna get to the end of this, but it's just like, why wouldn't they think of having, like, you can do Home Assistant on TrueNas. Not everybody likes to use Home Assistant. I know everybody's telling me to use Home Assistant, but I don't listen to you guys because you guys just suggest whatever comes to your mind first, right? I don't want to use Home Assistant, but the app for TrueNas that has Home Assistant has an MQTT server. I think it's got like Mosquito or something like that built in. The True Charts, which was a way to chart stuff in the server, has Mosquito built into the app. There's another one. There's another chart software, and I'm not sure. It might have Mosquito built into the app. Can I just get Mosquito? Because I'm already happy with Node-RED for all of my interactivity, and I could probably make Node-RED do some charting if I wanted it to. Node-RED doesn't come with Mosquito. What do I do? It seems like nobody's thought of just taking Mosquito and having that be a thing that you can do from their little tiny app store that has like 5 apps. It's got 107 apps, I think. That doesn't cover all of the functionality. One of them is a Pal World server that you can run off your file server, which is fun, but it's not what I'm here for. TrueNas and their infinite stupidity decide to use K8s instead of plain old Docker for apps. I've been bitching about them for this for years. That's what I'm talking about. There's like history. This is like when I got into modular synthesizer. Like that guy like went insane and did a racist rant, and I'm like, what? They're like, oh, that person is, they do this and they've done that. Oh, and that person ate a lemon once on stream. I'm like, I don't fucking know. What is this? I don't need to know all this history. Reminds me when I first tried Linux. It's all from floppy. I don't remember anything from that time. Kind of gave up. Didn't touch again for years. I used to run, I had a little thumb drive that I would use. And so I ran Lubuntu off a thumb drive, and I would use that to like browse the internet on a very old netbook. An old laptop. It was pretty good. It's pretty good. Sounds like the Minecraft modding scene. Yeah, that kind of thing. Where it's like there's just this long history, and you're like, I don't want anything to do with all this. Ugh. I did a makeshift lobster roll for lunch. Some of the roommates here went out and got lobster, and they're like, oh, we brought you back some. And I'm like, okay, I don't like lobster, but I decided to make a lobster roll, which was pretty good. But now I'm going to be all irpy because of that, because there's a lot of butter in that. Oh, I know. If they just used Docker, we wouldn't be having this conversation, because you could just grab the image, drop it on Docker Web UI, give it a port assignment, and be on your way. Yeah. Yep. Wonder how much more complex home automation will get before some open source community or company cleans it all up in a really simple process. I mean, Node-RED doesn't exactly do that, but I don't know. What is my friend using? My friend is using some such thing. He might be using Home Assistant, to be honest. He's got two environments going on that he sort of has bridged together in order to do his home automation. I like the fact that Node-RED is not automation. It's not home automation software, right? It wasn't originally intended for that. It has much better capabilities in my mind. I haven't used Home Assistant. I don't know what Home Assistant does, but I like the flows and thinking about things that way. It's a little bit more down to programming, like a microcontroller would. That's just, you know, I don't know. I could be totally wrong about Home Assistant. I don't know how that functions. The stuff that I want to get out of the automation in the lab can be done in Node-RED, though, because Node-RED is not strictly home automation. But everybody seems to be using that. Then Tasmota has allowed me to pull in a fairly simple way, pull all of the spyware out of the Home Assistant, or out of the automated, you know, like lights and stuff, because I don't want somebody to know when I'm turning on and off my light switches. And also the functionality of some of these automated things, they're crazy. You have to connect all of your internet to it in order to turn on and off a light bulb. It's nuts. So Tasmota has solved a lot of those problems for me in terms of lightening it up and making it work only as what it's supposed to do. But one of the things that you could do, like with Node-RED, is if your TV draws more current than it normally does, you can have it do a different lighting mode. So when you turn on the TV, all the lights dim, stuff like that. You get the real, actual home automation. All right, let's. I'm gonna volume down the orbital. Okay, get rid of start soon, and then hi, hello, it's me, it's Oh Bother. We're picking up where we put it down. We're picking up what we put down. We're dropping off where we wait. I lost the analogy. We are continuing. I almost said finishing. That would have been a lie. We are continuing the testing on Dave's module. Dave's module should have been a lot easier. Like most things around here, it becomes an exercise in how many yaks can I shave before I'm done. And that's infinite. It's yaks all the way down. But we're getting through it. We have vetted out the VCO. We know why it works. We don't know exactly how it works, but we know why the signals on it aren't exactly what we thought they would be. They end up being plus minus 2 volts because at the end of that VCO, we are both enabling an output and being able to take an input from other modules. So that then goes into our filter and then into our amplifier. So we now need to take a look at the voltage controlled filter. And this is something that is baffling, and it's something that's very complicated, and we've looked at it and we haven't really seen anything happening in there. I think what we need to do is we need to pull parts. We need to pull up a part and just see if it works or not. We could possibly try to build, now that I've got new breadboards, we could go down the road of building our own what's called a transistor ladder filter, and I'd have more confidence than that my connections are actually being made, and then we can give it 2 volts and see what happens. That is a potential there. If internet dies, home automation down, I should try Tasmota. I do have it on Zigbee or Z-Wave bridge device. If the internet goes down from my router, then home automation is done. But with Tasmota, at least I don't need an internet connection. I could unplug the router and everything would still function in here. But I've had troubles with power outages and IPs being weird. Anyway, so on this design, we were talking a little home automation stuff ahead of stream. Back to the synthesizer, the synthesizer. Let's pull that main chip that's a bunch of transistors in a trench coat and see what happens. I have documents that detail these different topologies and what the transfer functions come out to be, but it's a little bit much. It's a little bit heady for this stream. I don't want to revel in the math too much. We know that we have an analysis of these designs. I tried to internalize how they work, and I'm not getting it. It has something to do with the small signal properties of the diodes. The reason you use transistors instead of diodes is because a transistor is 2 diodes, right? That's how we test to see if a transistor is an NPN or PNP, and it's also how we test to see if a transistor is broken or not. If we get a short across 2 of the tabs of the transistor, then we know that one of the diodes has exploded. But it's basically a diode and a half sandwiched together, right? And so you can test that with the multimeter to see if anything's broken. Our multimeter testing said, there's nothing, everything's fine. So what I'd like to do is I'd like to pull the chip and then probe around and then maybe put a new chip in and see if that fixes it. I would guess that these transistors are the weak part that breaks if you plug things in wrong. Unfortunately, I dug myself a fairly deep grave with this one by plugging in the circuit board 180 degrees off, because for some reason the Germans decided to make it nice and symmetrical. They made it possible, instead of putting their, I don't know, put the headers like somewhere that's not, just don't make it symmetrical. It was perfectly symmetrical. You can flip it 180 degrees, plugs into itself. The 2 boards are off by a little bit, and that's your only indicator. And so when I was trying to test this thing out, I accidentally hooked it up wrong, and it exploded. It didn't explode. It would have been nice if it had exploded, but it didn't do me even that favor. So anyway, I've dug myself a deep hole. I think some of the more sensitive components on this thing have probably died. So let's just take that assumption. We're going to pull this chip first, this 5 transistor chip. That one is sitting right smack dab in the middle of the board. And what it is the transistor ladder filter. It's not the filter itself. The filter itself is these 3 that sit up above. But I did diode test these, and they appeared to be fine. So I don't know what the problem is. Keyed connectors, but I mean, nobody, according to the Germans, no one is supposed to be working on this board. It is impossible that they would try. Why would they try this? It is a working board. But yeah, the incorrect non-keywayed power plug caused the initial explosion of this thing, and then my own ineptitude caused me to plug it in 180 degrees inverted. You wouldn't really need keyed connectors from board to board internally on a device. Although they're nice, you could just have your connectors not be perfectly symmetrical. Ugh. So, different topologies of the filters. I guess I'm looking to see if there's more to this article, but there's not. And we were just looking at this, which is a TB303 transistor ladder filter. Now, we have the working document for this thing, not the, where is it? Where did it go? Right there. We have the repair manual schematic of the TB303. Now, acidlabs.de, again, like I said, they're doing other stuff with the TB303. They want ins and outs that are additional. So instead of having, for instance, an 5 to 8 volt signal running out to the switch and then back and then going to the next functional block of the synthesizer, instead they have those 2 signals come out and get switched, and then they become a plus minus 2 volt signal. So they are making them compatible with the ins and outs of a modular synthesizer, as well as allowing an external signal to come into the filter. So we know that our specs are plus minus 2 volts. Some of the values are going to be different. Some of the topologies are going to be different. For instance, this transistor pair over here, Q21, does not exist in the Acid Labs modular synthesizer, because instead they have a differential amplifier chip in that path. In addition to that, since we have control voltages coming in and controlling some of this stuff, like resonance, resonance cutoff envelope, instead of these circuit structures, we have slightly more complex circuit structures that allow control voltages to come in and influence things and mix with whatever, the knob setting is. So It's crazy. It's complicated. We're going to try to replace some major things here and see if it has an effect on the filter running. So let's start by actually removing that chip. Because, okay, well, actually, I'll power on and we can see what's going on. Right now, we are injecting this plus minus 2 volt, very clean sine wave into the insert for the VCF. So that's coming in, and if I probe, we'll watch the yellow line follow this. If I go to the resistor right here, we have exactly the same signal. It's just a slightly different voltage level. I think because this channel has been adjusted. Yeah, so let me adjust back down to 6 volts, and that'll be the exact same. Bonk. Yeah, there we go. So yeah, that's our input signal. It's coming into this resistor here, which is representative of this one right here, R6 220K. And that would be over yonder, over here. So you can see how much we probed this thing. We've been up and down with this fucking thing. We have 1203 coming in here. We have a DC blocking capacitor that appears like it's backwards. And I think the purpose of this is to keep the DC over here from affecting this stuff so that we're not pumping DC back into anything. I'm not sure about that. See, but it goes through that 120K and it just becomes tiny. The sine wave is barely even visible there. Now I could amp up the scope and show it. It becomes a filthy millivolt signal, but it's still there. Actually, it's a lot cleaner than the waves that were internal. It's a lot cleaner than the internal waves. I'll give it that. It's also offset in a weird way. But I guess when we get over here, is that going to put it back? Oh, there it is, yeah. So there's our signal in millivolts going into the transistor ladder filter. And we've picked it up on the other side of this thing. And it's noisy as hell. So then what? And you can actually see the capacitor has the effect of changing the phase just ever so slightly. So from here, where does the signal go? Where should we probe it up next? That's actually interesting because that's the cleanest that I've seen it coming into the next stage. So over here, we have it going into a 2.2K, which brings it to a 5.3 volt source. And we have it going into one of the legs of the transistor, the matched pair transistors. Now the resonance comes back through another 2.2K into another transistor. And then I guess this is the control for the resonance, right? So that comes over here. Yeah, and that's part of the resonance control. So on our board, we find it by using this document that we made, which is an image of the circuit board on both sides. I use a microscope for this because it's consistent. You know, it gets the same, whatever. It gets a phone from the same it gets a picture from the same parallax every time. So I took a couple pictures on that, lined them up in photo manipulation software, and now I have a top and a bottom layer that are exactly lined up with one another, as if we were looking through the board. So that bottom layer I mirrored, and then it was in the appropriate, well, mirror and flip? I forget which one it was. Anyway, the point is, all of this stuff tells us exactly what's going on. Now, we cheated. This is not something that we used to do. I thought you traced the line? Well, I did. I drew over them because that's easier than using image manipulation stuff in order to make sure that, you know, the traces pop out. You can do that, but then you don't I don't know. Anyway, point is, this is coming down and around, and it goes to this pin right here, pin 2 of the microcontroller. Sorry, microcontroller. Pin 2 of this chip that had the markings sanded off. It took a little bit of doing, but we figured out that this is, in fact, one of those 5 transistors in one package dealios. So we know the pin out of this thing. And they used one in another part of the circuit. That's how we were able to find this one. And then we had it confirmed by the PDF document that they use in order to repair M303s that have been plugged in wrong. So we go to the transistor ladder filter by virtue of this over here. Pins 1, 2, and 3. This we need to actually pull up a part number for so that we know where the transistors are. I mean, I also marked down where the transistors were to try to save myself some time. I probably should have just imported an image of the PDF, but there they are. These are my hastily scribbled transistors. So if I look at our entry to the filter, I got one here and then I've got one here, and they're both going into the collectors, and the emitters are tied to this pin here. And if we look at what our topology is, what our circuit looks like, in there we have our collectors going up to the diode ladder filter. So yeah, we've got pretty much what's going on there. Let's look for our waveform. Our waveform should be coming in at a 2.2K resistor going to that first pin. So that pin also goes over here, and here's the 2.2K resistor. So we've got our signal on that pin 2.2K. And that's it. That's all that it's doing. Okay. So let's check that out. I'm not really sure what it should look like after that. Actually, wait, let me change the trigger to the right channel trigger, and then we'll turn that to channel 4. There we go, that stabilizes it. All these wires out of the way, jeez. Okay, so, microscope is actually the better view here. That way I can bring you guys along with me. Okay, so that means that this pin right here, where's that one? That one is this one. Should have our waveform on it, only very, very quiet. Because, like, here's our waveform normally, but we've drilled down to the millivolt scale in order to grab it after this resistor. For some reason, the resistor has like a weird DC offset to it. So I guess that capacitor is helping to kill the DC offset. So now we are centered around 0. And then we have it here. And then we also have it on this 2.2K right here. On the other side of this, we have noise. I don't know what's going on there. That's part of the current stuff that's going on with the ladder filter. And then it also is being pulled through here. Funny though, I'm not really seeing anything going on over here. The base of this one is where, of course, we're getting the one signal. And then the base of this one is where we're getting the resonance signal, which is not coming through any of the resonance circuitry. What else do we have going on over here? This one being controlled by that noise. That one seems to be doing weird stuff. The probe is high Z, but sometimes it can have an influence on what's going on. That's why you see it dropping down like that. This is on some really sensitive piece of circuitry. All right, open the doors. Get them out of there. We'd like to discuss peace. Peace, no peace. What do you want us to do then? Die. Okay, anyway, sorry. My Independence Day flashbacks. Yeah, this is a mess. All right, let's get this goober out of here and see if that's the problem. I'm hoping none of these goobers here are the problem, because one of them's a PNP. I don't know which one. I have to look them up. I don't think these goobers are the problem, because this is the oscillation section, and there doesn't appear to be anything wrong with that. So this is the one that we replace. Let me get the power off. I guess disconnect this thing, our input there. Get the scope off the screen so you guys aren't looking at weird wave stuff going on. And then I'll put a little tiny bit of flux on either side of the pins, and we'll get the hot air gun over here, and we'll replace... Oh my god, there's dog hair all over this. What do I wipe it off on? I don't have anything. I don't have even a cloth nearby. Not even a Q-tip. Here we go. It's a little piece of scrap. This is not helping. There's just so much dog hair. It's... That dog... I mean, the summer has been hot, and so the dog's been shedding a lot. She's a Welsh dog. She's not supposed to be in the heat. So this is an SO whatever. This is an SO package, which are big enough that you would think that you wouldn't need something like hot air on. When I'm doing something like this, like, I mean, you could individually peel up the pins of this thing and get it out of there. I'm not even sure that this is the problem. We're just replacing it because it's the next logical thing in the sort of progression of things that are affecting our audio signal, and we're not seeing anything beyond this happening. The LM3048, or is that 6? LM3046? Plus, I have more of these. So let's get this thing out of here, and let me see here. I need a pair of long tweezers. Look, I have a pair of super long tweezers. I could just use my normal tweezers. My super long tweezers are over by the 3D printer, because they find the most use there. Yeah, let me just use my normal ones. If I can find them. Ah, they're there. Alright, so the trick with hot air, you don't want to just instantly get everything up to temperature. You want to kind of spread around the heat, because you want that circuit board to not have a relatively huge heat differential on it. You don't want to flex things, because you can break traces eventually. So you just subtly kind of heat up the area around, and slowly but surely focus in on the chip that you're trying to desolder. Now this one probably won't put up much of a fight, so if I get down there now, it should be pretty good. And that flux should hold in the heat for me. And I want to keep moving. Keep moving your heat around, because if you concentrate it, you can overheat and really damage the board. I'm seeing this flow over a little bit already. That might just be the flux melting. It wasn't just the flux melting. That was incredibly quick. All right, put the chips aside, and then I'm going to come in with a soldering iron. I'm going to clean up the pads. All that flux is going to help me out. You know, I need to trim this. The one thing that I don't want to have happen, because there's no significant ground plane in this area, and these pads don't really have vias on them, I don't want to put too much mechanical force on these pads. I want to make sure that my solder stays molten when I have this braid connected. And that'll just suck up all that additional solder and clean things up. If you don't do this, and you're using your tools at a super hot range like I am, you can cause damage to the pads themselves. They won't adhere to the circuit board substrate as hard as you want them to. Especially when you work and rework the thing. Okay, so I'm gonna... Oh, we didn't even power this thing down. What the fuck? I'm powering it off and then on again. Oh boy. In my haste, I didn't power it down. Let's turn the scope back on. What's up, Flask? How you doing? Let's see. Scope mode. Turn that back on. Bada bing. So, not much has changed. Huh. So that's now all the way up there. What's going on there? So that's there, and then we check it on the other side, and now it has that offset on it. Aha! So this is actually a result. What channel is that that's jumping all over the place? Quit your jumping. Channel 2, what are you doing? Jeez. So if I take this above the millivolt scale and take a look at what's going on here, we should have a millivolt signal that's being offset by like 5.3 volts. Yeah. 5.3 volts, but our waveform is all the way up there. Channel 2. So that stands to reason because we've got our 5.3 volts coming in over here. And then nothing is happening on these because there simply is no signal being transmitted through those transistors. Now the news. I don't know the BBC channels. I don't know them very well. Okay, so let's get a new LM something 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 and put it in there and see what happens. So I'm going to make sure that my power supply is definitely off now. That's an important one. And then LM 13, no, that's not the right one. I've got a bunch because I ordered stuff and then it took forever for stuff to get in the mail. CD 4106? No, I don't think that's the one. LM 3046, that's the one. Right, here's the one. Yeah, LM 3046. Might have blown up the old one. Luckily, I've got plenty of them. Made sure of that. You want to drop out? No. I should put these into my storage, but I haven't bothered yet. All right, so we know the orientation of pin 1. We know that Acid Labs likes their LM3046s. We actually identified the other one, the one in the oscillator, by what markings were left over after they tried to censor it from us. So there were trace hints of the markings on it. And with the help of chat, we were able to pull out those markings and do an overlay with a similarly marked chip. My lithium laptop battery expanded. Why do they do something like this? You should look that up. It's a great Google search. When the cells fail, they output, or they outgas hydrogen. And so the bag that the battery is contained in is designed to contain that hydrogen. The exact mechanisms I do not know for certain, and I can't recall immediately. Which brand of solder is the best smelling fumes? That's probably a function of how much lead is in the solder, I would think. So maybe you don't want solder that smells great. I'm not in it for the fumes. I got an agenda. So I spread the tweezers by inserting my finger into the base here, and that gets me wide enough to grab the SO8 package. So spread it wide, and then I can get my finger out of there, and now I've just got it kind of gripped with a little bit of pressure. So slide it into place like you do with surface mount electronics, and now that chip is floating in an awkward way above where I want it to make contact with the pins. So I push down on it, but I can't do that with that. I got to do it with the tweezers, push down on it. And it looks like it still needs to be maneuvered a little bit. So I'll grab it here and push down and just kind of twist it into the spot. Make sure that's nice and even. This is where parallax gets us, and the chip will be, you know, leaning over to one side. SO devices are very forgiving though, because everything's pretty big. You can probably still get leaded solder. It's just that if you're producing electronics, you can't use it. It's not about steady hands. The reason that I have the other camera on here is that you can see how I'm positioning myself, how I keep myself steady in spite of all the stuff that I'm doing. Right now, I've got my pinky finger on the post of this holder. My thumb is on the other post, and that steadies up my hands. It's not just about steady hands, you know. It helps to have steady hands, but you don't need them if you know how to position yourself. Much akin to welding. It's all about being comfortable. Comfortable. I'm doing these individually. I could probably drag solder them given that there's a ton of flux on the board, but I mean, you know, hey, this is visual ASMR. Of course, it adds too much solder to each joint, but I got the thinner solder in order so that I wouldn't totally blob out any of these pins that I'm soldering like this. Okay. So that's a new chip in there. If there is some type of problem down the line, we haven't solved it. So if there's something that breaks this chip on the synthesizer, we have not done a thing to remedy that. So it's possible something is still broken and our chip still gets exploded. Zero luck with drag solder. Flux. You need flux, and I mean, I have a partially leaded solder, so that helps. Stores no longer sell it, but you can import it. Huh. I don't know, it's so illegal. I mean, for rework, you know, we still can get the leaded stuff. It's, I mean, the formulas of non-leaded solder are fine. They work great. You know, you tweak up your iron and get it a little hotter, and then everything works out. So we can just send it, I guess. We can just send it. I can just turn this thing on, and we can see if this chip specifically explodes. Let me get a probe on something. Maybe we'll look at the audio, the supposed switched audio that goes up and around and goes to... Which pin? Hold on. So from there, it goes up and around, and it goes to this giant pad right here, where you would put a traditional canned transistor. So if we just take a look at that one, we can see what's coming out of this chip. I bought 6040 at True Value 3 months ago. True Value, man, I haven't thought of that place in a while. I haven't thought of that place in a while. We used to have a True Value near here. Okay, so we're looking at that pin. That pin is coming from this wave hits this transistor in the millivolt scale and then goes out to the ladder filter. So we should see something coming from this. I may need to tweak the knobs in order to get us to see more than that, but let's just see. So ready? 3, 2, 1, go. Okay, so it offsets it like by 1,000,000 volts again. And that's hard for me to see, so I need to go back into our millivolt scale, and I need to move channel 1 down. My arm's all up in the way, I know. Technically, I should probably be seeing something on that. So what if I adjust the cutoff, which is... this would be VCF in, third down. Right next to it is cutoff. Oh wait, why did my voltage level go way up there? Hold on. Why does it keeps like, look at that, it keeps jumping back up. Stop that. Why is it having trouble with this? Is it like a limited feature? Weird. Give me my waveform. All right, so cutoff doesn't do anything. Resonance, not yet. Envelope, that's envelope. That's not quite what we're looking at. Envelope and decay. Turn them all the way up. So what's the next stage do? Yeah, see, like I can't view it because it's offset, but I need it to be in millivolt sensitivity. What the heck? This one should be coming from resonance. Although, I guess I can look on what is it? So that's the center one, and then, no, this is the center one, and this one should be resonance, but we can't see it because of that giant offset that it has when it comes in here. So how in the world? There it is centered. And then if I bring us up to 5 volt, you click on the screen. No, it doesn't work. All right, so I need to zoom in to millivolts, and we can actually take a look at it here. There we go. So there's our sort of reasonable millivolts. And then if I take a look at it over here, I can then move this way down, and it needs to go all the way down until we're at 5 volts. So 1, I see, the parameter is limited. I can't go any further than that. I would need special test equipment, or to pause the thing and zoom, do like a wave inspector. What kind of capabilities does the Rigol have in that regard? Because this is a massive offset. I can't hold this probe here. I need something to hold my probe for me. One sec. I think I have just the right thing. I've never used it to any effect before. Yes. It's a probe holder, and it's for holding probes. Look at that, beautiful. I've finally been able to use this thing after 10 years of doing this shit. More than 10, but still. 10 years of streaming. Okay, so now I can actually figure out whether or not I can get this signal on here so that we can see what's going on. How in the fuck do I do that? Let's see. Measure, cursor, analyze. If I split screen... I don't think that... No, those are math. That's math. I mean, I could always... Wait, why is it still... It's at 10 volts? That ain't seem right. Is that the right pin? The wrong pin. That's at 10 volts. This one shouldn't be. Any of my controls do anything? I saw something happening there. One thing I want to make sure that I want to look at my output too. What is the output doing during all of this? How do I look at output? Output would be, I don't know if there's a test point for output, but it might be over here. That ain't doing nothing. That ain't doing nothing. That's 5.3 volts. Don't know what you're doing. I think you're just a transistor. And then output over here is probably not doing... Well, we don't have a gate signal coming in either, so we probably won't see anything over here. But then there's also envelope out. VCA in, is there VCF out? Envelope out. VCF control voltage, VCO out. Envelope, and then main out. How dare you? How dare you say that to me? I feel like maybe that component was not the problem. I don't really have a gate signal that I can put into this. How do you do that? If you turn the envelope mod all the way down, doesn't it trigger on noise? Maybe not. I don't know. It's still nothing. Right. Here's where the 10 volt was coming from. Well, I think over here. Apparently it's coming from a lot of places. so that one right there, going up and around, and then over to, hold on, here. Why is this at 12 volts? Because that's at the base of another transistor. Okay, so where's the 12 volts coming from? That seems to be a little suspicious. Little suspicious. Because it is pervasive. Who's got 12 volts on their other end? Those are ground. That one's ground. Oh yeah, I've got a layer for this. When we tried to figure out what the purpose of this chip was, we were tracing voltages throughout the board. So if you know where your voltages are, then you can trace down some of the unique properties of the chips. And you can see, you know, where's everybody getting their power from? And we did that. We did a little bit of that. I don't know how good it is. Yeah, there's that layer. Okay, so those are all my plus Vs. And what we noticed is that there wasn't a lot of plus V in this area. The purpose of that being, or well, the indicator, apparently the takeaway from that was that it's a bunch of transistors instead of being like a chip with a task or you know, like an op amp or anything like that that would get the power. So I don't know if there are other power traces around here. That one is. But most of these are going to ground. Most of these are going to ground. And the rest of them are performing functions within this filter. Some of them are feeding back into this circuitry here, too. Now this one, I believe, is an op amp, isn't it? Because, yeah, we've got ground here, and then we would have power over here. So this would actually be a V+. Although it doesn't seem to indicate that it is. Son of a bitch. Well, I thought things would be a little bit more definitive on pulling that chip, but apparently they are not. Yeah, this is something that we used to do in the IED job. Occasionally, when a circuit was really stumping you, you could do this, and then it would become more of a working document, and then you'd run from one end to the other, reverse engineering absolutely everything you could possibly get your grubby fingers on. Could be useful for me to do that, but I don't want to do that amount of work. I was hoping that we would uncover some other dysfunctionality of the circuit. From what I'm seeing, though, so far, I mean, everything in here, all of this stuff is sitting at 12 volts, which is odd. So why would it be like, how would that be accomplished? We may have killed a perfectly functional chip, or maybe those chips that I have are counterfeit. Although the VCO works. The VCO works, so the chips I have are not counterfeit. But yeah, our signal comes in here, drops down to the millivolts, humps the 0 line, and then it gets hit with essentially a 5.2 volt boost on that signal. Looking around for any positive power. What is this one? What is that line? Goes to the cap there. Huh. So this one is positive voltage. It doesn't do anything with anywhere else. Plus V over to there. That's the decoupling capacitor. And then 102, that's going into there. Goes back down and doesn't do anything with anything over here. It goes up to this transistor and that's it. There is no 12 volts. So where is my 12 volts coming from? How is it pervasive in this area of the circuit? There should be a power somewhere up here. Maybe that's what they're avoiding by doing that? No, there should be there still should be plus voltage going to some of these. Whew. Okay, I don't know about good old, but yeah. A little bit more of that on here. So where else have I traced plus V? Let's just see if we can find a likely candidate, something that would also be connected to the voltage bus. Plus V, and then plus V goes up and down. So if we go up, we go over to here, via underside of the board, via top side of the board under the chip, goes to that pin, goes to a decoupling capacitor. Underside of the board looks like there's a via. Yeah, there's a via that then takes it over to here. So let me get my pen on white and let me get that layer that has the V's on it. That would be this one. So this one's plus V. Needs to be slightly thinner. So plus V, plus V. That's for an op amp anyway. That goes plus minus. Plus V there. And then we go across over to here. And this is where we create 5.2, 5.3 volts. Hey, what's up, Makes Mistakes? How you doing? Been a little bit. Yeah, happy Friday. Trying to keep it kind of light here, but it always gets away from me. Plus V to the diode, plus V to the decoupling capacitor, plus V on that line. That line is then resolved. That's fine. We've got that whole thing there. That trace into there, into there, into there, into there, into there, into there, 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 there. So that's everything north of this junction. So let's go south of the junction and see where else our plus V goes. We've got it wrapping around here, doing all kinds of crazy bullshit. What's going on with that? That's just the big decouplers for the overall line. And then down here, there's a test point. And then it's supposed to be under the board, but the colors swapped or something. So that's going all the way out to here. And then up to there. So plus V there. Plus V here. I'm still in that right layer, right? So, okay, so that's all that stuff over there. Keep going this way. Then we jump under. Again, we go over to this trace where we drop off at a couple weird filter stuff. Over here, and then there. I think this is another one of those transistor doobly-doos. Either one of these. One of them is, and one of them is something slightly different. Let's see. Back over to here, we go north. We hit up this resistor right there. Via, drop down, come up and around to there. That's it? Interesting. So we fully mapped out everywhere positive voltage goes in this circuit. A couple little interesting places, but there's a big lack of it in this area where we're actually trying to figure out why there's 12 volts on a bunch of different stuff over there. Can you ever get more volts than if you reduce amps? Yeah, you have to do tricky things in order to get that to happen, and you get it in bursts. So you'd have to store those bursts in something like a capacitor, or it could then be output as a higher voltage. So text with the mouse skills are well practiced. I prefer to do it because it's hilarious and stupid and sloppy. We have a 5.2 volts coming into, not really quite coming into the circuit. It kind of comes in here as a reference. It's got a 1K and a 2.2K to fight as well to get through, and then it's sort of added on to our waveform, and that makes it a little harder for me to probe stuff. I could probe through a capacitor. I have this robot project that needs tiny movement. Do you have recommendations for a micro stepper that I can squeeze 2 of them into less than 1 inch of space? You'd have to look up like geared stepper motors. Geared stepper motors are a thing. So if you need really micro movements, a geared stepper motor will do that. A stepper motor will do some pretty small movements though, if you can just fit 2 regular old stepper motors in there. Other than that, I don't really know anything specific. And a square inch is not a lot of space to be dealing with. You can even do a universal motor with a gearbox and an optical encoder, but that's going a little bit, that's getting real cheap. If you do 2 stepper motors, you can get very small movement. Yeah. And then gearing will always help you reduce the movement and get more torque if you need it. But applications are all over the place, and I don't know exactly what you're doing, so. What the heck? I got a pack of micro stepper motors off of Amazon, too. There's some pretty tiny ones in there that are very interesting. Why do we have 12 volts? The diode ladder circuit should be going up to a 12-volt entity. If we look at the topology of that ladder, even this one, wait, come back. We can see up at the penis tip, we are hitting an area that is supposed to be a positive voltage. It's 12 volts through a 100 ohm resistor and then onto a bunch of different elements in this area. Got a 50 pack. Well, and you're not going to get gearboxes. Okay, there we go. I didn't get good sleep last night. It was very, very humid, and so I decided to jettison the covers, and so I had to pick up the corgi and get her to come onto just the surface of the bed and then toss the covers away. And she seemed to think that I don't know what she was doing. She was like, oh, what are we doing? Help. And so I threw the covers away, and it was this big mountain of covers that fell to the side of the bed, and it must have scared her, the poor thing. So she started whimpering, and I'm like, all right, Bubby, you wanna get down? So I was gonna grab her and put her on the ground to keep her from having to jump, but she decided that was the last straw and she was in danger. So she actually ran down the mountain of covers and then straight out the door. And it was like this one fluid motion. She was moving faster than I've seen her move in a little while. So I was like, sorry, dog, I didn't mean to traumatize you. But yeah, I didn't get a lot of sleep. I can't get no sleep. Bum 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 bum. Oh, speaking of house, our synthesizer is broken. Okay, we need to find what that positive voltage is at the top of everything. Now, those 2 capacitors seem to be nicely positioned. It's these little doobly-doos right here. These 2 little guys right here are positioned in just the right spot, because the next step of this whole business is the LM3700M, which is a differential transconductance amplifier. My cat does that on occasion. I felt really bad because I was gonna just pick her up and move her over, you know, and make it easy on her, but I think she thought, I don't know, she thought she was in some kind of danger from all the, you know, all the commotion. She was sleeping under the desk, by the way, before stream, and I had the audacity to start talking to my computer as I started setting up, and so she left. I don't think she hangs out in that hallway anymore either, which is really annoying. I thought she would at least hang out in the hallway. See, this is what bugs me, that 12-volt offset. Are we going to get 5.3 volts here? Yes. Okay. But our signal going in, that's going to be visible on the millivolt scale. This would also be oh, why is that offset now? For a little bit, we had this, you know, not offset to an extreme degree. We were able to actually see it on the other side of the capacitor as a waveform, which I don't know if that indicates that this is working or if it's not working. But we've got our ladder filter, and then we've got our final stage of the ladder filter right here. There should be more things that the ladder filter interacts with, a la this circuit here. And if we look at the paper, which is Moog ladder tf.dvi. It's Tim Stinch comb.co.uk/synth/moogladder_tf.pdf. You really want to look through some of the math here. But we should be seeing VCC, right? And I guess there's an alternate VCC that goes to the bases of these transistors as part of the functionality of the rest of the transistor ladder circuit. So why are we not, where are we supposed to see that? That seems to be, like, if anything else is going to indicate to me that part of this thing is broken, that would be the part that would indicate to me that part of it is broken, is that somehow that 12 volts is getting through everybody. I don't understand how or why, but then where is that part of the circuit? That's a resistor to ground. That's a resistor to ground. Here are our two capacitors that lead to the transconductance amplifier. So then from those, we go back into the capacitor. That should also share a connection to power somewhere. That's the input. What the? Oh no, that goes under, I see. Under there. Under there? That doesn't make sense. Wait, okay, so is this one of them? That might be one of them. And then the other one would be here. So these two are that last stage, and above them should be VCC. These two, so these two right here, the two diagonal ones on the end, are this one and this one. So we should see on the collectors of those, which are here and here, dun dun dun. So that makes sense to be at VCC, but I don't see VCC. He he he. Why don't I see VCC? What do he plea with me? Or C of B? I don't see it. Is there, am I not privy to some information here? This, like, over here, by all means, should have... And, like, there's plus voltage right over there. It'd be pretty easy to get plus V over to here. Seems to not be the case. Wait, what is this? Oh, that's a ground. Now, on the, what do you call it? On some of them, well, on the Moog specifically, let's get rid of that one. Transistors to VCC, but if you look at what's really there, there we go. You get this whole convoluted section where you have a 100 ohm resistor that actually goes up to power, and there's a whole bunch of other stuff that's connected to these lines. So is there a 100 ohm resistor that somehow connects this to this? Well, that one there, but this isn't a positive power line, is it? Well, we are getting plus 12 volts on this one, but I don't think that connects to the rest of the circuit. So where else? We're going there, go to this capacitor. That one goes over to here. Did I lose a VCC trace somewhere in here? Or does VCC come in on one of these other pins? That could also make sense. Because plus V goes that way. Plus V and minus V, plus V to those three. Nowhere else. This is making my head spin. Doesn't go anywhere else. So does positive voltage come down off of any of these? Do I get... And that testing probably won't give me a good answer for that, because if I find plus 12 on one of those pins, how do I know? How do I know if it's actually supposed to be plus 12 or if it's something else? Okay, so this one is 1, 2, 3. It's that one. Here he blows. Plus 12. What's that one? That's a curious... Oh, you guys can't see what I'm doing. Sorry, I was probing things. I was probing those pins. No, there's our buddy. Like, what is that one doing? Okay. What about... Okay, 1, 2, 3, 4, 5. That one's at 12 volts. Hmm. Is the key to this going to be tracing down all those positive lines? That's my question. Yeah, it's just looking busy. It's been here for years, and all it does is just go to meetings. I'm not gonna bark at my dog. Do we need to do a little path of discovery on the top board here? Oh wait, but this one. Okay, I missed this one. All right, so we're on white pencil, and I need to find my... There's the V layer. Probably have named these. Plus V there, plus V here. That doesn't get us any closer to the part of the circuit that I'm probing, though. Oh, plus V up here. And then another, yeah, another op amp. Plus V here. Up to... Huh? That doesn't make any sense. Wait a minute, that doesn't make no sense. If it's being used, maybe it's being used as a reference. As a voltage reference. Oh, or I'm getting the line confused. Hold on a second. Oh, okay, so this one is not plus V. There you go. So plus V just goes to these two pins. Oh, is that one? Wait a minute. Wait just a minute. Hold on. That goes all the way to there. Plus V, up and over, around, going to these. Then it goes under. Oh, I see. Okay, so I'm even wrong about that. So it's actually here. Yeah, there we go. I don't know why I got so confused. I must have scrolled over and just gotten weirded out by my own. So this one's also plus V. Down to here. And then it jumps down over to here where it's also plus V. And that goes there. Wait, that should short out to ground. What's going on? Wait a minute. That should be, by all means, that should work. But then maybe one of these is getting confused. FV is all the way over there. Maybe it doesn't connect this way. Because that would be just connecting positive to ground, unless this trace right here is ground. That might be the case. I don't see why everybody in this area is at positive 12 volts. It's the failure of something. I just don't know what. Everybody over here is at positive 12 volts. I can't even find 12 volts like where it should be coming in to the differential, or sorry, the transistor ladder. Because like this collector and this collector are at that higher voltage that should be pulled through the rest of the ladder filter. Now if we test that, part of the circuit, we do indeed get 12 volts out of it. I need to figure out where 12 volts is getting into it. Ooh, I'm gonna get more liquids. More liquid, getting heartburn. Did a makeshift lobster roll for lunch. It was leftover seafood. Delicious. I'm not a big fan of lobster. I don't really like giant bugs. Okay, so positive here, which we confirm it is there, but where is it coming from? We got 5.2 volts sitting all the way over there. We have this little cluster of capacitors that have a ground on one end, and then that coming over to there. It's expanding fractally. We need to track this down. Here's a 1K that goes over to that little cluster. Those like darling guys. It's not V coming back over there. Man, I'm stumped now. Every time we try to work on this thing, I feel like I'm digging myself a little bit of a deeper grave. And maybe I need to lay out the circuit a little bit more in the area just so I know who's what. But it does look like we have our positive voltage on one end of this thing. On the other end, I mean, for a little bit we were able to get an actual wave, and we are giving it exactly the amount of voltage that it wants. Plus minus 2 volts, the nice clean sine wave. You have a short, check for the lowest resistance. That's not really quite what we're doing here. It's a little bit more complicated than that. I can look at the lowest resistance, and that would probably be the 1K, but I have a feeling that it's going to test just fine. Let's do that. Let's do that, though. Let's do that. Let's just see, just so we can say we did it. Is the 4th pin also pulling 12 volts? The base of the resonance? Yes. All right, so output is off. I'm going to go into ohms. Move you guys over like this. As far as I can tell, the 1K is the lowest one in this area. And it is going into that cluster of circuit where we're looking at the higher voltage that's being pulled down on the transistor ladder filter. Oh yeah, 100 with 0 zeros after it, right? Yeah, so that's 100 ohms. This one is 1K. 2201. 2.1K. 102. Excuse me? (1002), 5.65 kiloohms. This should be 10 kiloohms. It might be other interactivity with the circuit. Got no potential across it. There's probably something else in the path that's causing it to be like this. Huh. Interesting. Bottom left corner was 12 volt stuff. Pin 3 over from that was also 12 volt. Pin 3 over that, oh man, that's very vague. So yeah, what I've been trying to do is trace out plus V, which is 12 volts, which we're seeing all over the place. That's a decoupling, that's probably an op amp, although there's another decoupling capacitor there on that pin. I wonder what that's all about. Oh, that's negative voltage. Yes, a negative voltage decoupling to ground. Positive voltage decoupling to ground, that's an op amp. But anyway, we're looking at where positive voltage is coming from, because all of the stuff over in this area where I thought this chip was bad, a bunch of pins of this thing are testing at 12 volts. So this would be the input stage here. This is the input stage of the transistor ladder filter. And then these two here are the what do you call it? There's names for this stuff. No, where is it? Where is it? Oh, was that All About Circuits one that named them? Input, filter, and output. So yeah, that would be the ones that sit over top of the output. Because yeah, if the output is here, you got things that sit on top of it. Let me just go to that. The TB303 is the model that we're looking at. It's essentially that. And we should be seeing a differential output, but I don't know what the transfer function comes out to be. I tried pointing it to on my screen, but you didn't see what I was pointing at. Yeah, I tend to not do that. I tend to miss that. It's a personal flaw. So yeah, input here, output here, and then that goes to the ladder filter. And these two combine, they should be getting 12 volts from somewhere, but I'm not seeing where. Sorry, I'm burping pretty bad. Ooh, man, that hurt. So this stuff here should be at 12 volts, possibly through other pieces of circuitry in this whole ensemble. So there's a capacitor here that's pulling it to ground. There's a resistor here. There's no voltage, there's no positive voltage anywhere in this area. It just doesn't quite get all the way in. We've looked under the ICs. We know it's not going under an IC. Voltages there, voltages there, voltages there. Ah. What's this one doing? That one does... Oh, I see, that goes under the board. Oh, and it goes to one of the pins over there. Never mind. Never mind. I am stumped. Now, if we probe this, we definitely do see 12 volts in the area, but there's too much. Everything is sitting at 12 volts. If I lower the settings, maybe I can get current to flow through and it'll drop down a little bit. Where's my probe? Where is my probe pin? Oh, that's right here. Okay, so if I... What's up, time scroll? What up? What? Nothing. Oh, output's off. So turn output on. 12 volts running through our system. That's sitting at 12 volts. Problem though, like everything is sitting at 12 volts. So if I look at, okay, that one's sitting at 5. 5. Okay. Did it like fix itself? Those are all sitting at 12. That one's sitting at 5. What does that mean for this? Sitting at 12. Damn it! Curse you! How could you do this to me? And then when I try the differential between these two, it's just noise. There's no wave in there. What if I look up here and twiddle some of the knobs? Let's see, the ones are, that's decay and resonance. Try some of these. Nothing changes. Nothing. Nothing. This is very, very frustrating, chat. I mean, part of it is that I don't really know what I'm doing. Like, I don't have the circuit exactly memorized, and I don't know where precisely to probe. We could try to build a version of this that would, like, work for our purposes on breadboard. And I think that's where we are right now, is I want to build this circuit, inject the, you know, get the proper voltages sitting on it and everything, and then inject our audio signal into it and see what happens to it when we mess with it. So let's build this circuit. What are we going to do about that? How are we going to build this circuit? No, I didn't actually. I got ones that were way too thin. I got ones that were, hold on, I'll answer that question in just a second. That's a big question. I got ones that were way too thin, and it occurred to me after speaking with some people who suggested it that the breadboard goes bad. The solderless breadboard just goes bad after a little bit of time because all the stuff you insert into it kind of makes the clips grip a little less. So new ones might, you know, might fix it. I know, really, I actually took an old circuit board that was left in this house from the 90s, and I compared those resistor leads to the old circuit board. Old circuit board has thicker leads. I think universally these resistors have short leads. Now, what is the problem? So Dave's synthesizer has been just a thorn in my side. Dave he bought an M303, right? And not initially, he used it for quite some time, but Dave's M303 eventually, like most M303s, got plugged in wrong. You have to offset the plug IDC cable just right for these things to work out. It's a design flaw. It's an Acid Labs design flaw. And I really hate that they made that design flaw, but because, you know, it kills my friend's equipment. My friends don't need any help killing equipment. The M303 seems to go out of its way to make sure that it's super easy to do. It is a non-keyed IDC cable that's too many pins, and then it gives you a plug that you can plug in offset if you want. But if you plug it in straight on, that kills it. You have to plug it in offset by 2 pins. So, Dave eventually, in a moment of weakness, blew up his M303. There's no protecting diodes. There's nothing like that. I offered to install them for him. He didn't want them. That leaves us with a broken module. Now, in order to test the broken module, I wanted to hook the bottom PCB up to the top PCB without it getting in the way. This is actually designed to have pin headers on it, and it plugs straight in. And that's all well and good for production, but I need to tune this thing to be 1 volt per octave. I need to do all kinds of stuff after I'm done fixing it. So I used flat cables, plugged them in, and they were backwards, and they kind of harmed the module more than usual. We then got, from Ben Gizmo, I believe, we got a document that told us exactly what parts are the ones that burn out when you plug this thing in backwards, which is incredibly helpful. That is an incredibly helpful document. I replaced the parts. It still doesn't work. So we've been getting down deep into the nitty-gritty of this thing. The problem is that it doesn't output sound. We've traced the voltage-controlled oscillator. We know it works. We know that it's outputting a 2-volt peak-to-peak signal. Or a positive, negative 2-volt signal. Sorry, not 2-volt. 2-volt peak-to-peak. What am I talking about? It is a positive, negative 2-volt output. So we know that part works. The voltage-controlled filter. If I inject this signal directly into the voltage-controlled filter, we don't see anything on the output. And the output being the differential between the two sides of this capacitor right there. We don't see anything on that output. So somewhere in this transistor ladder filter, our signal's been killed. So today we pulled the chip. By the way, an added layer to all of this is that Acid Labs did not want us knowing what chips were in there. So we've had to do a significant amount of reverse engineering in order to figure out what chips actually originally went into this thing. And we narrowed it down to a 5 transistor super matched, not pair, but it's just a thing. It's an LM30, whatever this one is, 3046 or something like that. So I swapped them. I put in a new one. Still didn't work. So I put in another new one. Still doesn't work, I think. The problem is I'm not totally aware of what precisely I should be seeing on the scope when I plug things in. So I think I should start building a transistor ladder filter on the breadboard, and we can inject our audio signal like we are here, and we can see what it looks like on the outset. So, the parts they use simple to decipher? No, they're not. When you reverse engineer an unknown integrated circuit in your design, it is very, very difficult to do. We had no information, and the markings weren't there. With the other chip, we were actually able to look at the markings and get a part number off of it by very carefully observing the color differentiation. But when you have a chip like this, where the markings have been sanded off, and you have no chance to decipher what's inside of that, inside of there, your best bet is to trace out the circuit in the area and figure out what the functionality is. And so it fits that this one is the exact same one as is up here. Or, wait a minute. Right here. This is an LM3046. This is the original one that had scratched off markings, and we actually used what was left of the markings in order to figure out what chip it was. That was a fun stream. We have a little video of the two being overlaid on one another. So it's like, what is this chip? This chip doesn't directly get power, so it's not some kind of an ASIC. What else could it be? Well, if we know that the structure is a transistor ladder filter, because we have cap, and of course this one is half the value of the next one's down the line, and we have 3 of them, that looks like a transistor ladder filter to me. So then you suss out what's going on in this area, and you go, well, it would be really helpful if this were a bunch of matched pair transistors, because the transistor ladder filter calls for several matched pairs in its construction. In fact, 3 for the Roland one. And so that brought me to the LM36 whatever. That gives us a bunch of transistors in a package, and they're super matched. Yeah, well, they shouldn't have did that, but now we know what their hidden parts are. Now we know. And then the only reason that we knew the LM, whatever the transconductance amplifier is at the end of the circuit, the only reason that I know that this right here is the part that it is because a viewer saw a circuit structure that they knew and said, what if it's this? Because I guess that's the part for a transconductance amplifier. So yeah, I have a game plan, but still. So we know what this is, but we don't know how this should look when it's functioning normally. So let's build one. Now, Hajiwo has a diode ladder filter. I want to see what his topology is. And maybe we can use similar values, and we can use the Moog design. I don't know what that is, no. I'm looking up. Am I looking up? Oh, Hajiwo. Diode ladder filter. So Hajiwo does a bunch of really cheap circuits. They're good though. They're really good, and they do quite a good amount of work. It's like synth stuff doesn't have to be necessarily expensive. Yeah, when you don't have the part number for ICs, it's very difficult to reverse engineer a circuit. So here's this note document. It's going to be in Japanese. I will translate to English. These are some big caps in there too. Now this is one that I've already tried to build. I've already tried to build this one. But now we have a better breadboard for it. Okay, so TL072 on that. He's got 3 diodes on the top there. So what is his design? His design is derivative of... is it Doepfer? Well, he's using 0.068. And he doesn't do the half value at the bottom. I guess it resembles early EMS. For 3-stage, 100, 100, 100, 100. He's doing 0.068. Really possible, however, a bit hard to tune it because you need to work with such high frequencies. This is for a reflectometry. I don't know nothing, man. Well, so their claim is, they rebuilt the 303, but they used modern components. And so they did a lot of work. They put a lot of work into figuring out what the modern component would be. So they try to keep it to themselves because they did all that work. They deserve a little credit for having done it. It's shitty for us because we're in a position where, because of what I'm calling a design flaw, I'm not going to accept it as anything else. It is a design flaw. Because of that design flaw, we have to repair one. It would be helpful if we could know what those components are. They're under no obligation to tell us what they are. But yeah. Those are for 2. Best I could figure, this design is... Excuse me, I'm sorry. I didn't get a lot of sleep. This design is early EMS. Early EMS. And then we have the control down there. Why is that doing that? Base to ground, and then... They weren't that simple to find out. We put a lot of work into that. Resonance is coming back from the amplifier. We got an amplifier on there instead of a specialty thing. I mean, we should be able to build this. And instead of diodes, I'm going to be putting in transistors, and we're going to build the Moog version of it. So the TB303 version of it, where we got the transistors there doing this thing. And then we'll figure out the rest. I'm not going to use the supermatch transistors. I will use transistors, but I won't use this. Well, I guess I probably should, shouldn't I? This one uses diodes. Nothing is mentioned as being supermatched, but I can throw the supermatched transistor thing over here into a little, what is it? A little adapter board. Technology to measure wire failures location using a singular electronic pulse. Oh, that stuff. Okay, that's pretty cool. Yeah, you hit it with the pulse fast enough and you look for the reflection. Yeah, that's pretty cool. Boop, boop, boop. Okay, well, this is going to be a significant thing to breadboard. This is going to take a little while. So let's get to work. So I have new breadboards. Just leave this over here with the output off. New breadboard, who dis? Brand new. And I got a couple of them if I need them. Let's get the scope out of here. Parts, I should have a wealth of the appropriate parts in order to breadboard this. So I need to get wires. I need to get resistors. We're using the ones with the thin leads. The ones that I ordered have just about the same size leads. Same size leads. You can see I'm very tired today, Chad. I did not get a lot of sleep. But I went and ordered this whole pack of resistors, and they're no thinner leads than before. I don't know what happened to resistors. Everybody's cheap about everything. I guess that's the whole thing about it. All right, so resistors, I have ins and outs. This one is another one just in case. Here's my in and out adapter that I made with the Donkey Kong connectors. Then I need other breadboarding supplies. So what do we got? We got transistors, precision capacitors, and then wires. That one's not even opened yet. Where's the one that I've opened already? Where did it go? Thing that I've opened. Where'd it go? Somewhere around here. Need to find a source of thick resistors. Yeah, the thin lead ones barely work in breadboards. That's my problem. Well, the metal quality has always been very terrible. That's never been good. Never, never, never. It's just that these thin wired resistors cause quite a bit of aggravation when combined with electronics breadboard, and we just have not been able to find thick ones yet, unless they're high wattage, which we don't need. We need just ones that are compatible with the breadboard. I've had circuits where I've had to poke it with my finger a bunch in order to get it to do anything, which is inexcusable. It's just terrible. Back in my day, resistors had wires. I mean, it could practically make all the resistors into pin header things, but not about to do that. I can't find the one that I've used already, so I'll just peel open a new one. All right. All right. So what is a good, well, I guess one that I have plenty of is a good one to use. BC556, that's a pretty cookie cutter one, right? BC556. This would be PNP. We need the NPN, so it's a 517, I guess. I'm just looking at which ones I have a lot of. BC517. Oh, whoops. NPN Darlington. There we go. That'll do. Wait, Darlington. We don't want it to be Darlington, do we? We don't want a Darlington. Oh, my darling. Darlington is when you have two transistors. The more sensitive one sets off the less sensitive one. It's like explosives. It's like high explosives. Yes, that's what we were saying. The thin wires don't work well on a breadboard. Okay, let's find one that's not a Darlington. BC327. Oh, that one's PNP too. Exapitapital. I mean, I could use the PNPs as diodes in this circuit. That's always possible because it's just PN junctions. We just want a PN junction to be in here. And to be honest, I guess the PNs aren't all that incredibly useful. So if I were to achieve PN junction, then I'm collecting I'm connecting. Let's see. So the way that they're doing it in the TB303 is they're connecting the base to the collector. Instead, I do base to emitter. Because if I do base to emitter, so it does base to collector, and that makes your PN junction there. Instead, I would do, well, I wouldn't want it to be two NP junctions. I would just do, if I just do it the same way, but connect it upside down. That's essentially all it is. So it'd still be collector to base, but I would do it in the opposite direction. Just as long as I'm going through one of the PN junctions on this thing. That's all we're really concerned with. It's kind of silly. Yeah, see, they're doing on an NPN, they're going to connect collector and base, and that way when you energize that, it will be going through both of these, but then it'll specifically be going through P to N. So instead, we can connect either of these, but we can have it specifically go from P to N anyway, just as long as we do emitter or collector. We could do collector, and then base emitter would be the output. So base emitter collector. Okay. So we'll do base emitter, BE. So 2 and 3. They always give you the 3D diagram because these things are so confusing. Oh yeah, it's so out of focus because we're working far away. And then let's get the scope out of here. We're not going to need that for a little bit. This is going to be a challenge to build. All right, new breadboard, who dis? So the main feature of this thing is going to be this ladder filter. So I guess I'm going to build that first. I should literally do it on a breadboard. So one of these days, I should get a wooden breadboard and build circuits on it. So, okay, let me double check my logic here. Base and emitter. That's the wrong one. There we go. So we are PNP, base and emitter, and that base and emitter is the output, and the collector goes from piece to piece so that we're going from P to N. In the other circuit, they do base collector, and then it goes from P to N. So if we do base emitter, and we come in through the collector. Okay. So pins 2 and 3, and we come from pin 1. And that would be our diode. So what I'll do is start setting these up. Like here, there we go. And so it'll go like this. I'll put them right here. I don't know if this is going to be the best spot, but... And then I've got to manipulate these pins into the right positions. How can I do this? Let's see. So this is one on its own, and then those two will go like that. So if I just bend this one back. Double check. Yeah, pin 1's collector. Okay. So that is now in a diode configuration, and the P junction is here, and the N junction is here. Double check. These are doing... I'm double and redouble checking my work just to make sure that I get it right. So it would be collector base on an NPN. Collector base. So we're going from P to N. So if I'm doing base emitter and then I come in through the collector. Yes, okay. Double, redouble, triple check. So how many of these are we going to need on this thing? I need 1, 2, 3, and then double up the stages with capacitors in between them. Okay, and then the capacitors, 0.33 and 0.018. We'll see what I've got on that front. So 0.33. Oh, are these off? Wait a minute. They don't have labels on them. Well, what are they? Okay, Hajiwa circuit for reference. 0.068 micro. There's 39 farad. The 0.047s I used up in the soldered Hajiwa diode ladder circuit. So 0.39 gets us close. Oh, here's 0.33 off. So 0.33 and then 0.018. Okay. So I need 3 of these. I want to make it a nice big feature on this board. So I'll probably actually move this one over a little bit. We want it to be a little bit more central. And I'll move it out to the side a little bit so that I can get this here. Oh, that doesn't cross over. What the heck? How am I going to do that then? It's going to have to cross over. This thing will have to be able to bridge that gap. One there, and then another bridge, another one of these. So this one like that. And then it's already to another one. I guess they're going to be really compact. I wanted to spread it out more, but I mean, the gap in the breadboard is for integrated circuits. This is the span of an IC right here. Maybe I'll just jump, maybe I'll do a jump over just so that we spread. I do kind of want to make this look like a diode ladder circuit. So at least it's reminiscent of what we're supposed to build. Let's see what my options are on that front. Because that way things aren't going to be so crushed together. Why isn't this thing opening? It's going to pop open and shoot wires all over the place. Oh, because there's a piece of tape right here. I didn't see that. It's clear tape on a clear enclosure. There's no way I was seeing that. What are your suspicions about the diode ladder? I don't know. The problem is I don't know what to do next. And so I'm doing this. I'm building this. When in doubt, make an analog. And that'll give me an impression of what's going on here. Plus, it'll be a nice little test bed for when I do the Hodgewoods circuit. Okay, now I've got this open. Tweezers. I know you were here somewhere. There. All right, and then whatever the smallest jump that I've got is. Actually, this needs to be probably slightly larger. The yellow wires. Oh yeah, this hasn't been broken in yet. Okay, so spreading out, putting the cap here. That goes to the other side. That, and that's 0.33. And then that would be my next stage. And then this will be the previous stage. So the previous stage, we have, there's going to be 3 of these. So I'll put that right here. And put another jump on it. We're trying to make this as neat and easy to follow as possible because we are confused. We don't know what we're doing. We don't know where we're going wrong with this whole thing. So our cleanliness in producing this circuit is vital. I don't want to leave anything up to doubt or weird circuit interactions or whatever. It's all just clear as day. That, and then the singular connection gets the cap. Actually, does the top one, that one is an output capacitor, yeah, so this goes up here. Okay, that doesn't plug in very nicely, but whatever. And then I need another, where'd my caps go? Wasn't there one out that, yeah, there it is. 333, right? Yeah, 333, okay. So, bend these out just a little bit. Here. These aren't really super matched, but they should be close as transistors. Oh, we'll just have to see. That's that side. Let's do the same thing on the other side, because this is symmetrical. Like this. And then more of these yellow jumpers. Man, they're doing such cool stuff with robot motors these days, and I'm sitting here back in analog, my ancient analog stuff. I've been following some Twitter accounts that have done some pretty cool stuff with these all new robotics motors, and they have one of these weird gear reduction drives on them that has like a wiggling gear. Very cool to play with. Analog is best though. Analog is endlessly fucking frustrating. I don't know where do you get off? I'm so mad at analog stuff right now. I have several modules that aren't working. Dave's synth has been taking precedent because it's been teaching me about all the other dead modules that I've got kicking around. Where do you get off? I've been having a little bit of fun. I have to admit, it's not all been pain. But I'm getting a little frustrated with this one, this M303, because it just, like, I'm down here in the weeds, man. I have to go all the way down to its bones in order to get any information out of any piece of this circuit. Analog's what you do in design and what you like. Damn. Well, you're made of sterner stuff than I am. I like digital, and robotics are, boy, robotics get you a lot more viewers. When my big board on the wall gets a little bit more love, we'll be looking at robotics stuff. But that's in the far-flung future. So I'm specifically using these PNP transistors here just because I got a lot of them. I think I need to switch over to generic NPNs for the rest of the circuit stuff. Just so I'm not too confused about what the circuitry is doing. These I'm just using as diodes. These are just being used as diodes, and they're ones that I would otherwise never really use anywhere else in the circuit. So what we've done is we've shorted two of the lines together, and then you've got one of the lines going back here. So it really is just a PN junction. It's just an equivalent of a diode. And I've mirrored the two parts of the circuit so that they look like a transistor ladder circuit. So now we need to build the input portion, and our input portion should at least be somewhat akin of the original 303 design. This is asking for a matched pair. Now, I don't have a ton of those matched pair. Those chips, the LM3 whatever, the super matched pair chip. It's like $14. So I'm not putting one of those in there. We're just going to put two transistors in there and hope they behave reasonably the same. So I need two NPNs. Someone allegedly so into digital, you're not nearly enough into a 1,000-page data sheet. Intricacies, interrupts, and peripheral registers. Listen, you didn't see me when I was doing the the AT-Tiny85 programming, because then we were into multiple different clock registers and stuff like that in order to get that working. And I did get it working. What's up, Lawlon? What am I looking up? I'm looking at BC337. BC337. These should be pretty cookie cutter. 45, 50 volt, 5 volt DC, EB. So yeah, we'll use the BC337 for the other ones here. Back to the DB303. So we'll want to connect that to the capacitor there. Oh, and that bottom capacitor. Wait, it's 1, 2, 3. One at the top. 1, 2. We need another stage. Yeah, we need another stage here. And that's the 0.18. May design some 4 VCO TB303s with the original parts, mostly 947733 transistors. Selected match many, salvaged from Yamaha Electronics. That sounds cool. And designed to develop, etched, etc. The circuit boards. Nice, nice. That sounds really fun. That sounds like fun. I have been eternally fucking tortured. I discovered that you can build a modular synthesizer by just getting a bunch of circuit boards, and my buddy Julian gave me some stuff, some enclosures to help kick me off on that. More like kick me in the ass on that, because I've been promising to build him a synthesizer for 20 years. And so I figured that you can just buy these circuit boards, and they're like, good luck, asshole, and they don't help you build them at all, which I love. I love that. I love that for them, and I love that for me, because that's the kind of thing that's really, really fun. And then I set to building a bunch of synthesizers, and in the interim, I've become incredibly frustrated. I've learned a lot about myself. I've learned a lot about my breaking point. Learned a lot about where I make mistakes on circuits. And then, in the end, the things that are remaining to be done are tuning a couple things and analog. I need to get the analog circuits working, so I need to learn more about analog circuitry. That's where we are. Part of that is, of course, fixing Dave's cursed M303, but the rest is me gaining skills. Someone makes mistakes. I am summoned. All right. Okay. And then that leads to the bottom portion. The supply portion we still need to build over here. So on the supply portion, we need our two NPNs, and they do base to base. They're both touching each other's bases. It's okay to make mistakes. Yeah, but they're very frustrating when you do. So, two transistors, base to base. I guess we can try to make that as symmetrical as everything else is. The base to base interface, all up in your face, is going to be kind of weird. And then we want the differential across, or we want to supply across that thing. So I'm going to get BC337s. I do have a transistor tester, but I think I need to get the tube scope working first. So I don't think we can use that transistor tester. So we're just going to have to do our best. And then the BC337 is collector base emitter, going from left to right with the flat spot facing you. So it's collector base emitter. And so our configuration is emitters go into the stacks. So this goes into the stack, and then the bases go together, and then the collectors go together as well to power. And then, where's our free? Right there, just like that. Hold on. Of course, it might behoove me to spread out a little bit on this one, since we have to get a signal out from here with a capacitor. So I should probably take this and extend it. Well, that's gonna stretch the transistor a little far, so maybe we'll just do this. Yeah, we'll just do that. That's a little tight for me. Actually, you know what? We'll jump it up. We'll jump it up. We need that jump up. Jump test. Gives us more room to work. Dismantle a Yamaha organ. I don't have access to that kind of stuff right in my shop. Plus, at this point, you're going to be paying a crap load for that vintage Yamaha. Yeah, these little jumps help space everything out. I could build this super compact, but I don't think that's going to benefit anybody. It'll just make me more frustrated, and me no like frustrate. Me no frustrate. That. Let's get the one over here. I don't know how far we're going to get with the breadboarding today. I don't know if we're going to finish this today. We'll keep working, though, because it's Friday. We can just hang out. But you know, there's a lot of circuit to go down. All right, so then the ones that are connected are going to be the next two are actually both connected together. So these get yumpers. I need bigger yumpers. I'm guessing it's going to be more of the yellow yumpers, isn't it? That's going to get expensive in terms of yellow yumpers that I might need later on. Eh. Some of the breadboarding kits from back in the day came with tweezers, and those tweezers were really good at gripping these thicker wires and inserting them into the holes. I'm not sure those can be gotten for free. Hold on, let's just... Like, all that stuff is starting to become vintage, and analog is starting to become more popular again. Where was it? It was Yamaha. Something. Oh, Electone. Oh, for free. $1,000. Those are, if you're getting those for free, you should turn around and sell them. Will I become popular soon? No. Maybe. Okay, so that's our input section. We don't have all the other nonsense that the input section has yet. I don't know if I'm going to be building an exact Moog replica, but we have most of the stuff. What else is actually required? We may need that RC, the 10K and the 1016. I think that's 10 of 16 volt. So let's see. If we look at the Hajiwo circuit that we're basing this on. Oh my God, I have all these windows open. Oh, that's an old YouTube video. Okay, there we go. Old YouTube window, I should say. Here's the Hajiwo circuit. So Hajiwo has none of that structure up there. He does not have the RC, which may be stabilizing something. I don't know. He does have a 1 kilo ohm resistor to the 12 volt input. And we're going to put 12 volts on one side, negative 12 on the other, and then ground in the middle. So let me do one of these, and we'll do a ground to ground. Ground to ground. Yes. Very good. Yes, ground over to ground. That might be too long. Do I have any shorter than that? No. These always skip out on the mid sizes. The desktop background? Yeah, it's Philly Skyline. You sure? Because I'm from Philadelphia. That's where we are right now. We are in Philadelphia. Anybody who tells you anything otherwise is fucking lying to you. So I'm going to do minus to... Well, actually, you know what? We'll do center to center is going to be ground. Center to center is going to be ground. And then plus and minus will be on the fringes. Plus V and minus V. There's no shorter... This always pisses me off with these kits. These kits are never helping you out. They're always like, hey man, you want to jump like 500 positions? You're like, no, I don't want to jump 500 positions. I just want to get from one side of the breadboard to the other without causing too much strife. What you do is you fold it in like this, and then you got this wacky noodle sitting on the end of your perforated prototyping board. Sorry, your solderless breadboard. Can't get those two straight in my head since the Hackaday commenters fucking tore me a new one over it. Anyway, so yeah, you do one of these little things. Okay, so input. What's happening with the base to base connection though? Wait a sec. So maybe we do need that RC in there. So 10K and then a 10 UF. 10 UF polar capacitor. Let's see if we can find that in the caps. Because yeah, I guess that's just something that's done on the TB303. I've got all these terminologies and I'm trying to get them all straight so that I'm not spreading this information on the internet. We've already picked this dry. We'll see. Yeah, so the Philly subreddit is where this came from. This one. And it's great because it's right in front of a baseball field. So this is taken from like a public park. I don't particularly like our pair of vape pens that Comcast brought to the fray, but it's a nice skyline because it's got a lot of yellow in it. It makes for a nice background. All right, 10 oof. 10 microfarad, 16 volts is fine. Although 16 is very close to 12 volts. That's a 1-off. Are we going to need a 1-off later? Maybe not. I don't know. Now remember, this is just our test circuit, and we're building this to get more familiar with diode ladder and transistor ladder circuits. I had to swallow a very nuclear burp. That's 47. Of course, doing the attenuation out. The attenuation input. Attenuation is just a 10K pod. I'm going to need a lot of controls on this thing too. It's resonance and attenuation. And I think there's another one on there. That one's frequency. Yeah, there's all kinds of crazy shit going on these circuits. How do you adjust all those different things? It's strange. Because our control is just current going down through the entire ladder. Is it like a current and voltage offset kind of thing? Maybe that's what that is. 100. I'm looking for 10. Looking for 10. Yeah, 10 of 16. Hopefully I can find it. $6.8. Come on, man. I mean, I know I've got it in the surface mount ones for sure. Like I said, this bin might have been picked dry. TB303 is one of the nicest sounding synths. I like me a good 303. I do. 100 oof. 100 oof. 100 oof for you, my good man. 3.3. I should probably be putting these in a different location. I'm pretty... Hold on one second. I'm relatively confident that we have a 10 UF in here. Another one! These are going to be a billion volts, but if they're the right UF, I might be okay with it. UF and puff. 100 UF. Come on, man. I need 10. I despise through-hole. I hate it. Surface mount is so nice and clean. And I can prototype with surface mount, but we're not prototyping something right now, so I'm doing a test build, so I need the malleability and quickness of breadboard. I crave ice cream. Go buy ice cream. That's not my problem. Fuck. You're telling the type 1 diabetic that you're going to go buy ice cream. Go buy ice cream. I don't give a shit. I don't fucking care about no fucking ice cream. Ice cream, I have to plan my day around. And so I just never eat it. I haven't eaten ice cream in years. It has been literally years. It's 100F. You're not going to have it. Well, it's good willpower. 6.8. I can't find 10. I might have to, like, adapt a surface mount module. I don't have to do that. Please be 10. 100. I swear we got 10s in here somewhere. I mean, I guess I could get a 10. No, these don't go high enough. These don't go into, yeah, those are nano. I have a big collection of surface mount. Probably not. 10 off. There we go. Found it. Pay dirt. Jeez, that only took an hour. Yeah, I'm not totally sure about that. There's probably some kind of a hateful diet ice cream that exists. But nothing ever tastes right in diet form. So why not just avoid it? And when the time comes, splurge a little bit, but don't overdo it. That has to go to ground? That's a strange... Okay, well, minus to ground, and then plus goes to the junction of those thingy-majigs. So that goes here to here. Really, the clean way to do this would be, since I can't really jump it out anywhere, I can flatten one of these leads and put it to the side like this. It's not my favorite thing to do, but if we're going directly to ground, I need to make this thing do the little skip across the creek. Just like that. So now both of my leads have enough lead on them, but now I can actually get the cap to straddle the slightly enhanced distance so that I can do this. Ta-da! So now we have the capacitor down on one side, and then the other one needs to go to the 12 volts. So we need a resistor across these two leads. And that's a 10K ohm resistor. So if we're doing a resistor across two leads, first of all, we need the resistor. Easy peasy, lemon squeezy. I got a billion 10Ks. Those are 1K, 4.7, 100. 1K. Wait a minute. What does that make you? I think that's the world's worst 0. I think that's what that one is. So I think these are the 10Ks. I failed to write a 0 properly. And then I only marked... Oh, there we go. 10K. All right. So yeah, these are 10Ks. Are these thinner leads than the ones that I bought? They're about the same. They really are. So we just go across 2 pins with this. But bother, you say, this device, this component, is wider than 2 pins of this solderless breadboard. And I say, fret not, little one, for we just do this. Yoink. And now we have 2 leads that are extremely close together, and we just clip them at the bottom. Boy, howdy, these fucking leads are really, really thin, and it just pisses me off. Ugh. Okay, anyway. Click, and then there we go. 2 even leads on that. That can just go right here. Actually, wait. Oh, yeah. That goes right here. And then it gets a 1K ohm resistor to positive. So let me actually put it down 1 row. And now we do 1K up to positive. .7, 100. Here's the ones. The ones and the other ones. Okay, so there's ones. Grab one of these. Now this has to span a particular number of holes. There's all kinds of tricks that you can use in order to get it to span a couple of holes. I happen to have a hilariously overpriced device for doing this. This thing is from Pace, which is why it's so ridiculously overpriced. But there are other, you can 3D print stuff off of Thingiverse. You can do all kinds of different stuff in order to get a device that does measuring from pin to pin. It helps clean things up. This stuff is all pretty cheap to maintain a supply of. So it's not all that necessary to try to save stuff in between builds. That's another one of those things that's kind of changed over time, is the cost of things has gone down so significantly, And the fact of the matter, I should probably be building this in surface mount just to begin with, because then I'd be absolutely 100% sure that all of my connections are being properly made. But instead, we are building it on the prototyping board because I want a little bit of the ability to reconfigure things. Not that I can't reconfigure things in surface mount, though. So I don't know. It's always a debate about whether or not I want to build something here or if I want to take it to the perforated prototyping board. But it's like by the time I do all the effort to put it on one of these, why don't I just design a PCB? I could make a testing PCB. It'll cost me $5 for 5 of them. I could make a 100 by 100 PCB, spread everything out, give it 1,000 test points. Yeah, this little thing it's a game changer. But if I didn't have this, I would have printed one of the ones off of Thingiverse. They're very similar tools. Yeah, I'm a type 1 diabetic, and I use the Android Auto Pancreas system, which means I can do this. There's my blood glucose level. Look at it go. Look at what lunch did. My lobster roll. Son of a bitch. Can you eat blank? Yes. With planning. I can eat whatever the fuck I want. Get that question so much. Okay, next matched pair. Matched pair of transistors. So the bases, the collectors go to the capacitor. The bases go in 2 different directions, because one's that feedback loop, and the other one is the, oh my God, don't tell me where my glucose levels are, please. And really, that is not up there. That's not up there. So one is our input, and the other is our resonance. Pick a number between 0 and 255 that isn't 69. 69. Jackie Chan. Damn it. Hold on. I'm busy. Go with 50. Base to base. So it's collector, and then the 2 emitters go together. And it's collector, base, emitter, if I recall correctly. Collector, base, emitter. Collector, base, emitter. So we want emitter to emitter, and then we want the collectors from the previous stage. And then I want my TB33. So I forgot the order. Collector, emitter, base. I always get this wrong. So the collectors go there. The emitters here, and then base in the middle, which is my insert point. So I want to give that a little bit of room to exist. We'll do there. That, and that. And then the same thing on the other side. Whoa. No one ran away from me. 50 it is. Huh. I don't know what I'm helping Brink do. I think I just enhanced security for something. Why wouldn't you want it to be 69? That would be hilarious when somebody infiltrates all of your security and you're like, oh no, you know all my secret passcodes, and the secret passcode is boobs. There's no way the nuclear code could be 0000. It's just not possible. It seems too stupid. But it loops back around to being smart. You want to absolutely humiliate whoever has to report what the code is. Like, what if the password for the nuclear football was a racial slur? Like, what if they did that? It's like we've hacked into the nuclear football. What's the code? It's like, can I whisper it to you? Do I have to say that out loud? I really don't want to say that out loud. Really don't want to say that out loud. No, you don't have any, you have no idea, boss. All right, so the collector, where does that go? Where does that go? Where does that get off? Here. So this gets into the complexity of this filter. What's happening is our audio is coming in from this capacitor over here, and it's going to one of the bases of the transistors, and that's allowing current to flow down through everything. Then it comes back out from resonance and hits the other transistor in the ladder. So we're making a differential signal out of the two of them that go through all of these diodes. And I don't understand it on any other level than that. I would need to look into this a lot closer and like actually work with the equations in order to see what's going on there. And there are papers that characterize it, and I have them open right now. They're all over the place. You can read up if you want to. If you want to, you can go to this URL. I'll give you the URL for free. You guys don't even have to, you just take this and you just go and you run with it, because I don't understand a goddamn thing about how this, I've read this paper. I don't understand it. We're doing something with, I don't know, voltage controlled current passed down through, and some kind of antimatter magic happens, and then you change the polarity and everything cancels out and you go to next week's episode. That's all I know. But yeah, it is a very clever design. Whoever came up with this is Moog. Whew, they're not paying them enough. So far, we have everything but the mechanisms by which to manipulate the current going through the stack. And Hajiwo has some pretty fancy looking circuit going on here. Boy, I really should have moved everything over, huh? Because we're like out of room over here. This should have been in the middle. I'm not going to move all this stuff. We'll just jump it over. We'll jump it all the way over to like over here. Yeah, it would have been a lot better if I could. Well, I could also do another breadboard next to it, but I don't think I really need to do that. Because they have two 6.8 kilo ohms into a TLO72, which I have, and there's two TLO72s, and we have our inputs, and we have three adjustments, a 50K, 10K attenuation, and then a 100K. But I have two 100Ks. That's my test setup. Those can fit on here somewhere or other. All right, well, oh, Jesus Christ, it's not even 4 o'clock? What the hell? Time crawls when you're doing analog electronics. Holy shit. All right, there we're set up with our ins and outs for whatever it's worth. That's going to get a little squirrely. So when we input, we go into attenuation, and then we have a couple resistors and capacitors, and then we go into the ladder filter. Let the filter scream. I can't yet. We don't have any ins and outs on it yet. So I guess what I'm going to do is do this over here, bring it a little closer to the rest of the filter. And then my outputs are the ones all the way on the left. The ones all the way on the right are my grounds. And I can wire those under that board. So I need to find the appropriate jumper, which is, again, probably the yellow jumpers. I've used them all up, though, so I should use something a little bit different. Let's go greens. Well, the greens are going to push all the way forward, aren't they? No, they can do pretty good. All right, so where are they going? I didn't leave ground connections on this board. Oh, they gotta be smaller than green. Smaller than green. Maybe these ones will jump over it. Eh. Yeah, those kind of work. I gotta figure out which rows I'm actually putting them on. So the first place that this thing fits, I put these little anchor pins on them, so it only fits in certain spots. It has to be like midway. I want to leave a little bit of room. I'm trying to spread out a little bit more. It's kind of like art. You want to spread out. Everybody loves making stuff super duper small, but one of my art teacher's big emphasis was to make your stuff larger. All right, let me just put the tweezers down on this, and then that'll tell me which one it is. There we go. I have one pair of tweezers on the field, so. All right, and then, so that one's there. I want this one. Okay, good, it's not at a gap. Those gaps are really frustrating. I don't know why they exist on this. They do the holes in groups of 5. It seems like it's almost an aesthetic choice to make the gap, you know, to have this gap here. It's like you could just have it consistent throughout the whole thing. It's like tradition that they don't put it there. Is there any forward, like any actual purpose for the gap in the ground and power planes these days? Even back in the day. Well, back in the day, some of them weren't wired together. So if they were super duper cheaping out on these things, they would be, all of the little clips that go in the back end of the plastic would be in groups of 5. But nowadays, they just crimp a giant one. So there's no excuse for there not to be holes there. No excuse. All it does is make me angry. And then I get mad at chat. There we go. Okay. So those are input and output plugs if I want them. And these are the cutoff pins. These are the supply. These are the it's mono, so it's not tip ring sleeve, it's tip sleeve. And so the tip connects here, this one's the cutoff, and then this one's ground. So that's just how that works. So now those are wired up to ground. Are they wired up to ground? They're not wired up to positive, right? Yeah, I wired up to ground. Okay. So those 2 are wired to ground, and now we have an input signal. And so our input signal is going to go through a little bit first. First of all, it hits an attenuation pot. So I guess I'll just put the pots on the other side here. Although, do we really need the attenuation in our test setup? I could just put it through a 10K and 33K resistor ladder, or voltage divider is what they do over here. Technically, we should probably cater it to our own thing, to the TB303, and have it go through a, well, 120 for the acid labs. Or do I just put it through? Well, there's the capacitor. That's 10 UF. It's another 10 UF. Darn it. Let's find a 10 UF. Let's find a 10 UF, and we'll figure out if we want to do the attenuation the same way. 10 UF. 10 ouch. First one. Nope, 4.7. I mean, I could also just do 1 UF 50 volts, because that's what's in this circuit. Remember, our whole purpose is to divulge, to figure out what the heck's going on in this circuit. Snips. There you are. Citizen snips. So we're coming off of this, and we have our 10K and a 33K and our attenuation. So we're coming off of this one. That one goes to ground. This would be going to here. Skipping one. And the direction of it in our circuit here is going into negative first. Oh wait, but there's still a, oh, this is the actually the last stop. Okay, so here's our ladder. We go in on this side. And so this goes to here with negative Oh, I see. They don't even say, they don't even give you the polar. They don't even give you the poles on the schematic. It's a ceramic. So I'm skipping over that one. That's the shared junction. We're going to the base there. Then there's a resistor thing that happens, and we're not worried about that yet. So that one goes in there. There'd be a resistor coming around. And from here, we go to a 10K, 33K. But in the circuits that we know, the TB303, we're going through a 220K, or if we're going through acid labs, which is what we should probably do, their values are going to be a little bit different, but we go through a 120K. That's this one right here. 120K, and then that goes into the capacitor and into the resistor ladder. So I'm going to put a 120 kilo ohm resistor on this thing. And that'll go directly to our audio input, which will be controlled at plus minus 2 volts. And the attenuation will not be a thing that we mess with, because I need these controls for other stuff. I need these controls. I don't know. I need them. We can't do attenuation. Uh, 220K. No, 120K. 120K. 120 kilo ohms. These are amazingly organized. See, the thing about sharing that link is that now chat is going to know way more about this stuff than I do. I don't have a value on those. And so they're going to come in here and insert themselves and try to run my show. You know what'll happen. Make sure I have chat up on there. 120K. Somewhere around here. 180. $150? I guess I don't have 120. I'll go with 150 then. We're going to have it be a little bit over attenuated. You do that without the link? Yeah. It is the nature of the beast, but it's also a beast. It's unfortunate that my input is on this side, because I really need it to be... I mean, I guess I could just skip over a bunch of stuff, but I'm going to need room for the rest of the circuit. So I guess I'll just jump it over here, and then I'll go flat jump over there. So we'll go until we get to this pin. So from here to... Is that the right one? One more. There to there. I like keeping the resistors run simple, and then when things get more complicated, when things get much more dense, then you start doing all these weird jumping things where you bend wires around, you make it look fancy. But keeping it as simple as possible makes it easy to follow. And the ease of following is the whole, like, it's everything in perforated prototyping. I keep saying that, and I keep meaning breadboarding. Wow, I made that way too long. Hold on a second. I screwed up. I messed up. KSS is your friend. I don't think we're going to get this powered today, and I'm debating on whether or not I'm going to stream tomorrow, which is Saturday, which I normally don't stream on, but you know, I need makeup time because I've missed a lot of streams lately. The file server thing threw me for a loop, so I mean, I guess keep your ear to the ground in case I do stream tomorrow, but don't expect it because I might just be too burnt out on everything. And I probably need a day or two. I need another weekend to work with the server, let's be honest, to get that all back up so that I have all my automation working again. and I can get back into the swing of things. At some point, I would love to figure out how to get my whole setup into the other part of the basement so that we can do a 3D printer table setup, because I need to set up a 3D printer station over there. I can move both printers over, although I have all my FDM supplies in the corner over there, so maybe I won't do that. I don't know. I'm debating on whether or not I want to do that. I can have like a saw station in the other room, but there's like works of art in the other room. Like I don't want to mess with chippings in the other room. But if I can move the resin printer into the other room, and that way I'm erect when I'm actually working with it, meaning that I'm standing up straight. Perverts. But not having to kneel down to get to the printer is going to make it a lot more functional for me. And then I could maybe move the ultrasonic cleaner into the other room, although that's a very disruptive piece of equipment. That thing is nasty. Okay, so that's our one side. We've got our input coming in from the outside, our plus minus 2 volts. Now we have just a mess. Just a mess. And that mess is responsible for dealing with resonance and having control over the resonance. And in the case of our other synthesizer, it's also managing a control voltage input to adjust that resonance. So it's basically doing current over whatever. But boy, oh boy, there's a lot of stuff here that I don't think I really want to replicate. This is insane. This is a lot of stuff. What does it lead to? Envelope mod, envelope decay. Envelope decay actually goes, yeah, somewhere else entirely. But like these go up and over. Envelope mod and resonance. Jeez. What is all this? There's like a pot there. I don't know if this is like the Acid Labs is going to have kind of a different design, huh? A totally different design. But Hajiwo has a nice simple design. And I like Hajiwo. He makes good circuits. Where am I going to put the amplifier stage? I guess it's going to have to be way over here. It's a pretty simple amplification stage, to be honest. TL072, 2 resistors, 100K feedback, plus minus 12, 4.7 oof, and then that feeds into resonance. And save that 4.7 oof. But that means wires are going to have to go way across the board. I'm going to stretch my legs. Yeah, what is going on with that? I've got 2 transistors down there. One of them is, the base is grounded. So our ground is our reference. And I guess if we go below ground, it'll allow current to go through. Weird. Weird, weird, weird. Let me go down 4.7K to negative 12. So let's get that part wired up. Let's get that transistor in there. So that's going to be another BC337. There's a BC337, right? Hold on, let me check. BC327, and then PNP is the 327. Yeah, so we're using the 33s. They're the NPN equivalent. So we need a 337. I used PNPs in the ladder just because I have them and I don't use them as much. So CBE, collector base emitter. And then this transistor has base on ground. Collector goes to the shared collectors. So that's this piece here. Collector to the shared collectors, base to ground, and then emitter to more of the circuit. So I might as well just put it over here and then do a jumper to base. That's easy enough. There we go. That's all that needs to be. And then do a jumper to ground. That can be this guy. Just gonna, you know, like, I just can't win. That right? Yep, that's the ground. And then the emitter goes to more stuff, which would be in the Hajiwo circuit. This whole other side of the op amp. So I'm going to need to get the op amp too. This is where the fun begins for sure. So we've gotten rid of attenuation. Our in is just coming directly into the same resistor. 2.2Ks, those are the same values that are in the Moog design, so that'll help. I don't know about this 12 volt, 10K, whatever's going on right here. But yeah, it's, you know, we're getting closer and closer. This is just starting to pan out a little bit more and more as we go. Let me build the stuff that doesn't require the TL072 yet. Instead, I'm going to do the other transistor 12 volt 4.7K, and that's coming off of both collectors. Okay, so that means that both of the collectors here, sorry, both of the emitters here wire together. The other one being going to 12 volt. How am I going to do that? And then the base goes to the... That one goes to ground, and then the other one goes out there. That one goes to 12 volt. Okay, this is complicated. Positive 12 here. Going to 4.7K. So I can actually pick that up wherever I need to. I can put it over here if I want. The shared pin is the emitter, CBE. That's this one down here. And the collector of the other one and the base goes to somewhere else. So if I take a BC337, these transistors, like, you work with them. I've worked with these since I was a kid, and they're tough because they're three-dimensional. Through-hole is very confusing in that sense. If you find a more eclectic part, like a weirder, rarer part, you will not know sometimes if the datasheet is looking down through the part or up from the bottom of the board. And that causes a lot of confusion, causes a lot of things to explode. That's just working with it. The better datasheets, of course, will tell you where they are, and then almost the universal standard after a certain amount of time of working with these, the universal standard for the transistors is to have them in an isometric view so that you get a three-dimensional view of which pin is which. These emitters share. I'll just go boop, boop, boop. Actually, leave one hole there. So there's that. Now those two emitters are now connected to one another. The collector of this one over here, oh, of course it doesn't align. It doesn't align because there's a block there. We can just make it a little crooked. That one gets a 4.7K to positive 12 volts. Which ones are 4.7s? Oh, that's this one. The one that I am holding. These are useful in audio, apparently. I don't know exactly why. Just the way the math works out. Use another op amp, 358. No, I'm using TLS72. We're trying to replicate a circuit here. There's a little purpose of what we're doing. I don't want to use a different op amp. And I have plenty of TLS72s. I stocked up on these when I started working with this stuff. I mean, if I really wanted to, I'd fully replicate the TB303. Then I'd be able to move that over to like a more permanent installation and have my own 303. Part of this is that the more I understand the 303, the more I could make my own module with all this stuff. That's a long road to go down, but it's you know, I will have already had the design, so I could probably move it to Fusion 360 and then just have a PCB printed up. That would be kind of neat. Yeah, this is where I'm getting a little bit more compact with the design, and I got to kind of fight that. I don't want to be totally compact with this design. This is supposed to be spread out so that I know what's going on. No, I've got a bin full of them. Make sure you have parts like that. The TL072, TL074 are like vital if you're going to be working in analog, musical stuff. Those are your Jelly Bean, whatever's your Jelly Bean, Jelly Beans, Jelly Bean op amp. Whew, man, hello brain, how are you today? This thing is all lopsided. These probably should have been over here. Okay, where else can I build? 2.2Ks to 10 UFs to 10Ks. Those are all just part of the resonance control. And there's no CV for resonance, I guess. TV uses 3/5/8. Yeah, some of them have warmer sounds than others. The TL072s are good for your control voltages and stuff like that. TL072 and 4. What was the one I was using? MCP 6004 is a good one for 3.3 volt systems. But the LF 358, whichever one that is, that's got decent sound. That's what my microphone is coming over right now. It's I think an LF 358, if I can recall correctly. I replaced them with that because it gives a little bit more warmth to my voice, especially compared to the TL072. Woof, there's a lot of circuit to go here. The bass to the bass, input from the 10UF, and then we've got our own thing there, and then I've got to do 2.2Ks to their own little juncture. 2.2K. Do I even have 2. I might not have 2.2K. I might not have it. I have 1Ks, and I could just put 2 of them in line with one another in the laziest and a striking example of laziness. It's 2.2 ohms. If I had 1,000 of those, $22. I'm getting close. LM358. It's pretty remarkable. Remarkably hated op amp. It's the only widespread one with significant crossover distortion. See, I don't, maybe that's what my audio getting scratchy is. But we have this Electret microphone, this German Electret microphone schematic, and I tried TL074s or 2s or whatever, and I tried whatever that other op amp is, and in the end, it doesn't really matter. No, shut up. In the end, the one that sounded best was the LF358. LM358, sorry. The LM358. 2.2 to 2.2, 2.2 to 4 to 3 to 4 to... there's so much circuit in this circuit. 2.2 off of the bases of these two. One of them has that going into it, but I need to get the 2.2s to get along. Let's go to this one here. The 2 on 5. For those that aren't aware, these part numbers are used to identify different chips, and so whether you like it or not, in this hobby, you eventually start memorizing the numbers. And it's not cool to know what things are by number. It's very dorky. 358 had a certain character. Good for the TB303. The TB303 is it's rough. It's you know, it's not supposed to be prissy and pristine. It's sort of dirty and acid housey. That's what's so great about it. The music instrument, the flaw might as well be the advantage. Yeah, exactly. 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 This is my hubris right now. I've gotten it. The circuit is a little compact, and it's starting to kind of get in its own way. Unfortunately, this isn't a quick build. If I actually had wherewithal to know that I would be doing this today, I had sort of a little bit of a supposition that I would be working on this part of the circuit. But if I actually planned for it, we could have hit the ground running, and I probably could have built this whole thing in a day. But unfortunately, didn't quite work out that way. All right, how do I do this without junctioning them? I had not anticipated that. Getting out of that part of the circuit got me into some trouble. I can move this back and then move this one forward. So that's the thing with these, is that these rows are all connected. So if I run into a problem where I'm crossing over something, I can actually move a component away. Those I remember to hook it up the right way. Move a component away, sacrifice maybe a little bit of testing ability. Do it crossways like that. And now I can put that resistor all the way up here. Actually shorten this and make it a little easier on myself. So instead of the green, I'll put it in yellow. Actually, no, this one will do. Checking over this circuit is going to be hell. It's not going to be fun. A good thing to do when you're doing stuff like this is put on something that's not too visual. You should have a nice collection of media sources that aren't too visual. You put it on and you listen to it while you're working. Because what we're doing is we're one-to-one replicating a circuit. All you need to do is keep your wits about you. You don't want to, you want to make sure that you're not accidentally miswiring something because you're not paying attention. I'm trying to move these back as far as I can so that I can fit the resistor in here. Resistor needs a little space to breathe. Not really so much space to breathe as it is just it needs to not short out the other resistor. Everybody's moving back a hole. Move back a hole. Nothing to see here. The problem with doing that, though, is that it reduces the amount of testing spaces that I have, places where I can stick a multimeter probe. I'll tell you where to stick that multimeter probe. That dropped on the floor. That's a drop, if anybody wants to register that. I don't think anybody's around that remembers drops. What if instead of LM358 you meant LF353? That might actually be what it is. I don't remember. It's in the VOD channel somewhere early on. Is LF353 the high quality one or the really sensitive one? I forget. All right, so now both of our resistors are going to this row here, which is not being used for anything. And I can jump it across, and that makes our 2.2K junction. Oof. We're clawing our way to victory here, bit by bit. Classic microphone op amp. I don't remember what's so special about it. Oh, nice. You got the drop. How many? 1038. So since I first started working on Burn the Subs, when I got a spare table in here and I had all the Maker Beam stuff all spread out over the table, and I was making the frame for my XY axis, since that day, I have dropped 1,038 things. Now, there are some times when I drop like a bunch of screws, and that would count as one, because sometimes people get a little slap happy with the command, and they want to try it for themselves. Yeah, I think it was an LF353. I had one in a bin, and I put it in there. In the mic pack, I'm not too sure which one it is. All of my mic is post-processing, and it's done in VFDs. It should be done physically. I would like to make just like a little box that we do all the tuning in. So many things I've dropped and some lost. Yes, they immediately hit the floor and enter the cat dimension, as is expected. 10 oof and 2 10Ks. That shouldn't be too hard. Wait, 10 oof and 2 10Ks. 2 10Ks from 12 volts to ground. So it's a voltage divider. We've got equal value top and bottom. So that's going to have the voltage. 12 becomes 6. Is that a 6-volt offset that we're giving that right there? Perhaps. That very well may be. Interesting. So is that what the 5.3 volts is doing in the Moog, but this one is using a straight-up voltage divider. Also, my wedding ring once found 6 months later with cleaning the garage. We're looking for Willow's collar right now. We had to order another one, like another full collar set for her. But somewhere, and I suspect, I'm starting to think it was me, somewhere around there is a dog collar. And so I've looked everywhere. We've gotten to the point where I've looked where things will drop off of surfaces in order to find this dog collar. And we still can't find it. It's so frustrating. Just not knowing where something is. Okay, so 12 volt, 10K, 10 off. Something here is creating like a bias, and I don't really understand it. Did you know that corgis are capable of hiding their collar? Well, then it would be buried, because she buries stuff. Maybe she buried it in her bed. Buried in the backyard. We have an alleyway. We don't really have much of a backyard here. Not much of a backyard. Now, the thing is that this junction right here is where those 10Ks go to. I guess I can build it from end to end. Yeah, if I free up that hole, I guess I can go... Well, that goes to ground. That would go here, which is really short. So I can go right here with that. And then I can put a 10K there. And then I can put a 10K here. This will have to go the other way around. This circuit is starting to really get on my nerves. There we go. Okay, so 2 10Ks. It's buried under the floorboards. Harry. It's from Plinkett Reviews. Jeez. Okay, and they're doing one jump, so I guess I'm gonna have to stand these up. That makes them a little bit more susceptible to getting brushed and destroyed. I've already tossed. It's already been a laundry day since it's been lost, so I've already tossed my laundry a couple times, looking for the dog collar. It shouldn't be in a car, because she always wears her collar on car trips. It didn't slip off. I think I put it down somewhere. I think I put it down. I think it's probably my fault. Actually, that one could lay flat, couldn't it? Yeah, I think these can actually lay flat from where they are. I forgot that there's distance to cross to get to the planes. Yeah, that'll be able to do that. I just need to clip the other lead. Clip the other lead. Lay her down. See, just the amount of clipping that these things do in order to hold these in place, it feels bad. It's just not correct. Everything about it feels loose. Because these thin leads, these microscopic, like, needle leads that come off of these things. That would need to be longer. Junk resistor. Yeah. Into the garbage. Another 10K. This one goes to positive, which is oddly compact over here. And then the one that I'm going to struggle to do is the... that's directly the size of a resistor, huh? The one that I'm going to struggle to do is getting the capacitor in there. There should be a 10 UF cap to ground. That's going to be tough. I don't know how I'll do that. Oh my god, dog's going crazy. It's something outside. Woof, 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 woof. She's barking her head off. Ah, come on, man. You need like pliers in order to do this. There's like thicker tweezers that are pretty good at this. My surface mount working tweezers are not adequate for doing breadboarding. They're okay. They're not great at it though. Okay, those are the two 10Ks. However, there's also a capacitor to ground on this one. And in this case, I'm doing this row as ground. So what I can do is jump up to the one next to it and get that capacitor right in there. So let's find a 10 oof. As if I have any more of them. We've already used 2. Can that be like any value? I wonder what that 10 UF is doing. It might, I don't know, it might be frequency specific, but it seems like kind of a non-specific value. Because a lot of the non-specifics in this thing are 10 UF. There's another blocking cap that's 10 UF. A DC block. So 10s might just be a go-to for Hajiwo. Like this one's 1 UF. Can I use that? I'll probably use that as a DC blocker. 47. This one's probably 10, but the leads are too short. It is. But the leads are too short. Leads are way too short. I can't use that in the breadboard. Need a little bit of distance on those leads in order to get them into the breadboard. Into the bird. 1 UF. 47. 6.8. 4.7. Come on, man. I can't win with these. We probably used a lot of them in like other breadboard things. Another one. $3.3. If I could get close to 10. Otherwise, it's just going to get 1. It's another 3, 3. 3, 1, 10. What about you? Please be the right value. 47. Ah! And like, what is it even doing in this part of the circuit? What purpose does it have? It's stabilizing. That's not the part that allows current through, but it would be doing some kind of a filter on what's being used in resonance. It's so complicated. I don't know. I just don't know. I just don't know. All right, well, you guys don't have to suffer through more of the build here. I know it's, you know, people find it interesting, and we've got a lot of... Oh, I found one. Hold on a second. It's just the second I start to threaten to stop, we immediately find the appropriate one. So if I put that here, going towards ground, this is pretty much the only place I'm going to be able to fit it. Just like that. And then I jumper ground over to the other lead of the cap. I need a longer lead than that. Or no, wait, that top one is ground, yeah. That'll do just fine. There we go. Okay, so what still needs to be done? Both of the sections where the op amps are. Those are the two sections. Those are going to be hard to build in. Did I do the 4.7K to ground on those two? I did not. Let me get that in before I forget it. And then the remainder of it is just getting the op amp stuff done. So I'm going to try to maybe do that on my own, see if I have time for that. I do want to start doing uploads again, so those are going to take a little bit more of my time as well. If I can swing that, I'm not sure. I might just take a little bit more time off from doing those, because I was pretty burnt out on doing the VOD uploads, but we do have to catch up to present day still, though. Oh, sorry, Kavorka, I didn't see the vet has it when he coned her. Not sure. Oh, no, that was a long time ago. The vet does not have the collar, no. No, that was a long time ago. And the weird thing is you have memories of the object sitting in places in your house, right? Like, I know I saw it somewhere around there, but that might have been a month ago, it might have been a year ago. Where does that one go? The 4.7 goes to negative V or ground. It goes to negative 12 volts. Oh, that changes things. How does that work? How am I going to get over to there? So that has to go to negative 12, and there's no clear path. Actually, I could go across the gap. Here, this will be a better view. So right now, I am trying to get negative 12 volts. Hold on. I have negative 12 volts all the way down here. That's what this is, negative 12 volts. And I need to get it to the junction of the two emitters, collector, base, emitter. Emitter and emitter. So these two have their emitters connected to this row. And I need to get that to negative 12 through a 4.7K resistor. So I'm going to put it here, and then I'll be able to jump from here to negative 12. So I need to rebend my leads straight down. And so this, janky though it may be, goes here. Wait a minute. Hold on a minute. My leads are all messed up. Okay. I need to cut them a little shorter, don't I? I think the dog is freaking out because there's people walking their dogs outside. So I need to go socialize my puppy in a little bit. And I don't want to just endlessly breadboard. I think the next time we do something on the breadboard, I need to slow down and I need to bring you guys with me on the journey. I need to go through all of what I'm thinking. You guys need my entire thought process on what my decisions are. And that would benefit the people who are looking to learn how to breadboard stuff. I want my content to be basic enough that anybody can follow along. But my brain goes too fast for my mouth. So I end up babbling quite a bit. But, you know, talking yourself through a project is part of streaming. We just need to do some more zany stuff. We need more zany projects. I need to get more people in here. More people. Okay, so there's that. That's the ground. Those are the two. Did I miss? I missed. I'm over one hole, aren't I? Yes, I missed. I screwed up. It was here. Ooh, that one oddly satisfyingly well. In the pursuit of fixing this thing, we will come back to this, maybe not immediately. If I can get my server stuff done, we need to work on Node-RED, and I think that would be a fun change of pace where we actually get to do stuff in the physical world. You know, we get to control stuff. But in terms of when we work on the Dave synthesizer next, I want to have this circuit more fleshed out, because it's sort of a little bit of a hybrid between the two filters, and then we can send signals into it and see them filtered out on the other end, assuming that I build it correctly and it's not another frustrating boondoggle of a circuit. That 1974 circuit book is on my shit list because I keep trying to build those circuits and they keep failing. Part of it, though, might be my old breadboard not making good connections, although this one feels very similar. This feels very similar to the old one in that those resistors are just kind of like loose in the clips. They're not totally loose, though. There's a little bit of tension from the clips. Those little pieces that like are supposed to do the thunderclap. You know, when you move a mattress, you get like that on it. That's essentially what they're doing to the wires. But with these little tiny like needle thin wires, they don't really make all that much grip. It's horrible. Resistors, you know, very low margins selling resistors. And so in order to save money, in order to make money, you save money, make money. In order to save money and make money simultaneously, you use less metal. And so you have very thin wires on all of your resistors, which is totally fine if you're soldering resistors. But if you're doing what we're doing, this relies on there being a slightly thicker profile for that resistor. All right, I've had enough. You've had enough. I'm going to take a break from this. I'm going to come back to it and finish breadboarding, get all the stuff down, get the TL072 in there, and wire it all up and get that ready to go for testing the next time we work on Dave's synth. Dave's synth is taking up a lot of space and a lot of brain space for me, so I want to get this thing done. We may continue to hit this thing until it's done. Have you tried tinning the leads? No, that might help a little bit, but it's also going to be so inconsistent. And then when you tin it, the thicker lead is probably going to break easier. Although that's not that big of a deal. So I have not tried that. It might do something, but it might not do as much as I'd want it to for the amount of time spent. So anyway, thank you. Hey, thank you for all the subs and everything today. Everybody today was when we triggered a hype train. There was a bunch of people subbing stuff, right? Yeah, a hype train at level 2. Whoa, 2. 2's actually pretty significant for this channel. We used to get super duper hype trains because of the board. We'll come back to the, you know, getting the board working. I need to get my file server working because that's going to be the front end for all of the other stuff in the shop. So anything you guys are able to interact with, it's going to start with that file server and Node-RED. But until then, I got my weekend cut out for me. If the planets align and if there are no sunspots or something, I might stream tomorrow. Don't count on it. Don't count on it. I hate to disappoint everybody, but yeah, I'm thinking about whether or not I want to. But do you raid? I sometimes, but there have been times when I've raided, like, you know, like friends that I know, Djibouti show, I've raided, and then people in the comments are like, "Oh, this is not my style. Like, this is too energetic for me." They'll comment that like in the stream, and I'm like, bro, they were doing like a St. Jude charity stream, and like people had the audacity to make that comment. So I've cooled off on raiding. I don't really want to like play favorites or anything like that. I can look at who's around. Okay, definitively, I do not see the two people that I would like to raid more often. I'm just gonna check, make sure. They are definitively not streaming right now, so there is no chance that I can raid them. Polarin is doing Makers and Crafting with no viewers, and then Ella is doing Ella has raided me before when I'm doing My Summer Car, so. Oh, she's doing GTA. And Roboz is doing the Slavarian Trucker, which looks like a really fun game, to be honest. I should get my setup running for that. But other than that, I'm not seeing anything. I'm going to leave you guys to your own devices. Here's the end card. That'll have some information for you. You can check me out on Discord, which is where I'll be hanging out. Once every 900 years, I make a Twitter post. So if I have something interesting to go up, we'll see. I probably don't. But I will catch you guys later. I'll be back on Tuesday at the latest. Go be prolific. Touch grass. It's always weird when I take a little bit too long to find the end screen, because the end screen is kind of down there on the list of things that I click. So there's like this weird, like, pregnant pause before I actually find the scene.